Is it good, Jason? Okay, so today we are going to have 3 presentations. So you will get 3 hours of CEUs. The first one that we're going to have today is Scott Dappin. Scott is with SkateAware. Sorry, I thought we were having a meeting, but we're not. Scott is with SkateAware. SkateAware does a lot of work for us in Galesburg, so I helped line him up for today. This was actually a follow-up from a conversation I had had several meetings ago with somebody who was wanting to know a little bit about how to troubleshoot SCADA issues, who to call, whether, is it the electrician you should call, is it an IT person, or is it a SCADA person? So I got a hold of Scott, and he's here today to help us troubleshoot those. So here's Scott. He's going to tell you a little bit about himself, and he will take over.
All right, thank you, Brandy. Scott's got to go up here. All right, can you get, is it doing anything? Can you guys hear me? Okay. How do I actually, can I use the keyboard? So thank you guys all for coming and sitting through this and watching me do a presentation. I put together some information from a systems integrator's perspective on troubleshooting control system issues at water treatment plants. And like Brandy had said, kind of how some of the division would line up between systems integrators and electricians and IT people. So Brandy, thank you for inviting me to present at this. I appreciate the opportunity, and I appreciate your guys' your time watching me. So I would appreciate after the presentation, I'd like to be able to send out a survey form to you guys to see what type of value you guys receive from the presentation as well. If there's things that we could do to improve, I will say this is the first time presenting any of this material. So if there's things you guys find useful, it would be helpful to me, and I'd appreciate feedback. Nope. Is this thing? Oh, that's only, all right, I'm sorry, I'll speak louder then. I thought there was some sort of speaker system. So first of all, I'll kind of cover who SkateAware is. We're a systems integrator, and we're based out of Normal, Illinois. Basically what a systems integrator is, for anybody who isn't familiar with the term, is we're the guys that do the automation. We do the PLCs and all the SCADA systems in water and wastewater plants. SkateAware's been around since, I think, 2000, and we have established expertise, obviously with the name SkateAware. We do a lot of SCADA. And we've established expertise in the water and wastewater market. We have several other vertical integrated markets. We do robotics. We have guys who focus on agricultural and people who are working on primarily on manufacturing. A lot of what we do is projects execution. So bid projects when you're doing upgrades at plants. We do the new PLC controls and we install the SCADA systems. And I see some of you guys out here we've done some work for. We do the SCADA systems, PLCs. We do handle networks inside the plants for the PLC systems. And we do telemetry, the radios and cellular modems that communicate remotely. We do support and work on instrumentation, especially integrating it into control systems. And then we do integration of any field devices that interface to the PLCs. One of the newer things that we offer is integration services, and that's it's more of the service after. I guess it kind of started as service after the sale. We do projects, build a system for a customer, and install it. Well, one of the focuses of the company now has become being able to provide service, just support for existing systems, whether it's SkateAware provided system or whether it was put in by somebody else. Help with maintaining and documenting the systems. troubleshooting, which is the most typical, failure response, something goes down at your plant, being able to respond to that and help get you going again. Operator training for anyone who wants to learn to be able to help you guys support your own systems better, and then small project work for plants. So I guess what we tout as resources is being able to provide just kind of supplemental resources, right? You can't normally, a lot of places cannot have a SCADA guy on staff that knows all of these systems. So it's nice to have somebody that you can call when you need it. And obviously having extra resources for emergency response. If something fails, it's nice to have somebody to call. So as Brandy said before, this is actually the text from her email. Request was given by one of the Heart of Illinois Water Pollution Control Operators members. Do I got that right? That a common problem that operators and managers face is that figuring out who to call when there's an issue. So how is the problem best identified, and who is best qualified in different scenarios? So I built a general agenda for this, discussing the roles and capabilities of different parties when responding to issues. Actually, if you're bringing in new resources to your facility, how to evaluate and try to identify the right providers to be able to provide that support. And then looking at some common failures and scenarios in wastewater plants. So move the mic up. All right. That's all right. Hopefully, yeah, let me know if it's an issue. So I'd like to talk through some of the common failure scenarios. I've said the things that we see a lot, but what I'd like actually is to get feedback from you guys at that point and say, hey, these are things that you run into, things that you'd have questions on and would want some clarity on. Cover some general troubleshooting guidelines. It's actually kind of the process that we would follow, but there's a lot of steps that we follow as integrators that, plant operations it might help you to do some of those activities on your own. Talk about some preventive maintenance and proactive preparation, and then ways that you can utilize your SCADA system to help more quickly identify problems. So the people that are involved obviously with this is plant operations and maintenance, the integrator, electrician, and then the IT group in many cases. So the operations and maintenance involvement, which is you guys, right? You guys have all the knowledge of the process. You guys understand how the plant works. Many times, if we're really familiar with it, we'll understand how the plant works to some extent, but you guys are the ones that know a wet well should be at 8.5 feet. When we walk in and we see one of those, we don't necessarily know what the process conditions are going to look like. You guys are going to understand historical issues with the commitment or with the equipment, what failures have happened previously. You guys are also going to know any changes that have been made to the process, right? If a motor's been changed out recently, or whatever has been modified in the process. So, and then the other big aspect that the operation maintenance team can bring is what are the ramifications of any testing, right? So when we're on site, it's really critical to have the support of the operations people to know if I start this pump or with whatever it is that you do, what are the ramifications to other parts of the process? And I will say, as a systems integrator, being the guy sometimes on site, when you're working on something and you might have a pump or a check valve closes or something, and it Is it good? We're good. All right, I'll keep my hand out of my pocket and away from the microphone. So an integrator, like I said, since they programmed it, a lot of times they do understand some of the sequence of operations, probably at a more of an in-depth ability than an electrician, certainly. Familiarity with most automation controls, we kind of hit everything. So most of the things that we see, if something's failed on site, even if we didn't provide it, we've seen it before. Generally gets, electrical troubleshooting, terrible at electrical installation, but generally pretty good with troubleshooting of almost all electrical equipment. And normally one of the, I guess the stereotypes with integrators is that, they send out a mechanic and they can diagnose a mechanical problem. Well, if they don't find it, then the electrician gets sent out, and then he has to diagnose whether it's a mechanical or an electrical problem. He kind of has to know both. And then the integrator, then they get sent out. They have to be able to diagnose all three, because that's just kind of the nature of the beast. And then the integrators also have programming tools that aren't at an electrician or an IT person's disposal, right? We can go into the program, we can see a limit switch isn't being made, or there's a pressure is reading incorrectly from something that might not be visible to somebody else. So it's really the troubleshooting and diagnostic capabilities of an integrator are going to be the strengths. And then also on the networking side, generally have in-depth knowledge of anything on the SCADA side of the network. We have to be able to see if networking is the issue, communications between different devices in the plant. And so those are the things that an integrator is going to be capable of. This is an example of what not to ask of your integrator, though. Don't ever ask them to run a piece of conduit. This isn't something that we actually ran, but that's just an image of it. So mechanical work, anything with piping and plumbing. I would say motor controls under 10 horsepower. Your integrator's probably going to be able to deal with it. I probably wouldn't ask anything larger than that. Anything with power distribution. I would say most of the time with instrumentation, as far as coming on site, changing things out, smaller motors, those are the things that you'd probably ask of the integrator. Anything inside the PLC cabinet would be within the integrator's realm. Anything on the network, anything with the computer systems. So next is services that would be provided by an electrician. I think it's pretty straightforward. Anything that's dealing with power, right? Troubleshooting issues related to electrical components such as wiring, circuit breakers, or power supplies. They're probably going to be able to identify issues in the power distribution system faster than an integrator is. So, they're skilled with the installation, maintenance, and repair of electrical systems. They're going to be much more capable in performing a lot of the repairs than an integrator is going to be, and that's just being straightforward. If it's changing a motor out or swapping a pump or changing valve actuators, an electrician's probably going to be able to do that more quickly. And certainly if you have repair of damaged conduit, if it's repulling wires, that's going to be more within the electrician's realm. Now, I will say that, I don't know if that's stereotyping any electricians, because I do see some electricians that have really, really good capabilities, even from an integration standpoint. Some of the guys can go in and program PLCs and do some of that. So it's going to vary, obviously, depending on who your provider is. But I think these are just kind of the general rules of thumb. As far as the IT provider, each facility needs to determine their own level of isolation. When you've got an IT guy, where's the line drawn between what the IT guy does and what the integrator does? I would say as the integrator, I would always advocate for facilities to kind of draw the line at the SCADA system and allow the integrators to own that network that everything communicates on, because it's super critical and it needs to be isolated from everything else in the network. So that would be what I would advocate. But in some facilities, the IT people do want to maintain ownership of anything that has an Ethernet port on it. And if that's the case, it makes it, then they have to be involved with this side of the process as well. So, like it says on here, the IT provider is nearly always responsible for the administrative network. They're normally the biggest piece that they are associated with is just punching that hole between the networks and allowing outside access to the SCADA system. So if everything's working at the plant, but nothing's working to get into the plant so that you can see it from their offices or from home, that's going to be on the IT provider. And so that should normally be the dividing line. That would certainly be our recommendation. It's also their job then is to make sure that the SCADA networks are kept in check and that they're reviewing policy on SCADA systems and managing control to make sure that things are being done securely. And I don't know if anybody in this room has been associated with a security breach, but there have been instances where there have been massive losses even on SCADA systems because that piece has not been properly managed. So that's why I highly recommend always keeping SCADA networks completely isolated, and the only access you allow through that is anyone who absolutely needs to have it. So. And then the next is OEM equipment suppliers, right? A lot of the equipment that you guys have, you bought from an OEM. So pump systems, blowers, compressors, centrifuges, filter systems. A lot of times, especially on newer equipment, it's going to be warranted. So you're not going to want anyone to touch that other than the OEM. Certainly, once things are out of warranty, electricians or integrators, the same kind of rules apply to everything that we just talked about previously. But I think I just have this up here to make sure that if, when you have warranty issues, and also if you have maybe some specialty parts that only the OEM can provide, especially like maybe disinfection systems, it may be prudent to always keep the OEM involved with maintaining that equipment. But I think whether or not they're maintaining your equipment, it's always really important to make sure that you communicate to the OEM providers that that you're able to get all the complete documentation, right? You bought a piece of equipment from them. You should have all the PLC code. You should have drawings for all of your equipment. You should have bill of materials for all the parts that they provide. So that's something that with the OEMs really to kind of close the loop on and hit home is to make sure that they realize it's your equipment. In evaluating service providers, this kind of goes across the board. Always before you bring somebody in, make sure you understand what their experience and expertise is. Make sure that they've seen a water plant, they understand the equipment. They're not just a PLC programmer, because it's really important that they understand what it is that you guys do. Check references and reputation. Obviously, you guys have a really good network of references between you guys. You bring somebody in, you probably know somebody who's used them, so it's good to talk to those people. Also, just go online and look at reviews for different organizations. Ability to provide for dedicated team coverage. Make sure it is whoever you're bringing in, they're not just telling you, hey, we can provide service for you. Make sure that if they're bringing somebody in, if you want a named resource, you know who that's going to be. It's also really important that you know if a named resource is provided, that the backup to that person is also known and that those people are trained on your site. So if you do have an issue, you get somebody who knows what they're doing. Obviously, make sure insurance coverage is good. Check on communication and teamwork. Ask them how do they manage service with customers. They've got, as far as how are they communicating, is it via email, but when there's issues, how are they closing the loop to make sure that you know what's going on. Cost and timeline, you're going to always look at the cost of your provider just to make sure that I don't think it should be the number one factor in your decision, but obviously cost needs to come in. When you're looking at integrators, specific considerations, looking at track record and reference again. Make sure that you look at different projects that they've done that are similar to your site. Technical proficiency in the specific platforms. I don't know, like show of hands, how many are, if you know, Allen Bradley facilities? I would say that a lot around here, a lot of facilities are Allen Bradley shops, but make sure that whoever it is understands the platforms that you guys use. So it's, you know, Allen Bradley, Schneider Electric, Mitsubishi, these are just different manufacturers of PLCs. I'd say the majority of what we see around here is Allen Bradley or maybe Schneider. SCADA software, same thing. Make sure that they have experience with the instrumentation that you guys have. And it's also important to look at the industry certifications that they have within the integration space. CSIA is kind of the organization that a lot of integrators are affiliated with, and it kind of dictates your quality control, the way that you run your projects. And the same thing is also check to see what manufacturers they have partnerships with, right? So if you've got a partnership with Rockwell or Schneider, you probably are going to be better able to service their equipment. Then also service level agreements. You know, how do those work? What kind of response time is guaranteed? And then, you know, what are the terms on on service response? For IT providers, it's really very similar. Expertise in those systems, compliance and security. I think in the IT side, there's more regulatory items that, like the NIST cybersecurity framework. That's something that's cybersecurity could be a completely different presentation. Partnerships with vendors, whatever infrastructure you guys have on your site. If you're bringing in a new IT person, make sure that they support the equipment that you have, and then look at their scalability and future readiness. Make sure that, you know, obviously that's a space that changes very quickly all the time. Make sure that they're staying current on their knowledge. With electricians, I think it's pretty straightforward. You know, you want to know that they're licensed. You want to know that they're doing work in water and wastewater plants. You get different areas where you might have somebody that does mostly residential or commercial work. Well, that's a lot different than somebody who does water and wastewater work. I'd say the water and wastewater and maybe industrial electricians have a really good crossover, and I'd look for somebody who has that type of knowledge. And then if there's any local codes and regulations that you have to follow, make sure that they understand NFPA and NEC standards. So just going to look through a couple different scenarios and just talk about what the troubleshooting path that would be followed in each one of these scenarios. So these are just typical things that failures at the plants, right? A motor or pump won't start, a valve won't turn, instrumentation fails, maybe something fails on the PLC system. I don't know if you guys have, is there another typical failure that you guys see a lot that's the thing that you need outside support with? And then, networks not working. Troubleshooting motors and pumps. Say a motor won't start. The first step from my perspective is when a motor does not start, obviously you normally probably notice it because SCADA system or the control system should be calling for the pump to run, and pump's not running. So the first thing to do is to figure out, you kind of take the whole system and you cut it in half. Is it the SCADA system or is it something out at the motor itself? So if you go on the SCADA system, verify, is the SCADA system calling for the pump to run? Okay, looks like it's calling for the pump to run. But for whatever reason, things not running. Well, if you have local control on the SCADA, flip it into manual on SCADA, try to run it from there. That'd be the first step. It's going to at least eliminate, see if there's something wrong with your automatic control sequences. If it doesn't start from that point, then You go out locally to the pump, and then, this thing's distracting. And then try to run it from the HOA, right? So that'd be most pumps you either flip the HOA into hand, or go out to the VFD, put the VFD in local, try to start the pump. So that's going to, and if it does start at that point, you know it's probably something with the control system. Then you start looking at the control system. That's when you say, I'm going to call the integrator, right? Because it's probably something that's within their jurisdiction to fix. If you put the pump in hand and it doesn't start locally, it's a really good chance that it's probably going to be something electrical that an electrician's going to fix. So, but the next steps, and I don't know how much in the weeds that you guys normally get as operators and from a maintenance perspective, but then the next step is going to be, check power to the motor. And I'm not sure how many guys are carrying meters with them, but this is kind of that step where if you got a meter, you're comfortable with it, you kind of can go through some of these other steps. And this is what the electrician is going to do as well. Check power to the VFD or the motor starter. If it's a VFD, go on the face of the VFD. If it won't start, if it's got a fault, it'll normally tell you. It has a display on it, and that'll kind of send you down the path that you need to follow. Inspect the motor. Make sure the motor's dry. Make sure it's not excessively hot, right? It could be cavitating. It could be, the pump could be cavitating, and you could have a process problem that's causing the motor to trip out. If the VFD has been changed recently, then you go through and check parameters in the drives. That would be really not probable under normal operations unless something's recently been changed. Check wiring for any loose connections or corroded connections, and verify things are grounded properly. That's something that I would expect an electrician normally to be doing. Obviously, an integrator could be doing that too, and just checking the pump for damage or wear. Make sure that obviously the impeller is not clogged or obstructed, and that's something that operations people are usually going to be much better at identifying than the integrators. And then check for any external interlock signals. And so a lot of times, especially submersible pumps, will have like seal fail relays on them or over temperature relays. See if there's any ancillary devices that are going to trip your motor or pump out, and hopefully they have some sort of indication on them. And if you get to that point and your motor's tripping, VFD's not showing fault, you're probably swapping your motor out, right? Troubleshooting instrumentation. Obviously, the first step is to identify the issue, and in my opinion, it's go to SCADA, right? You go to your SCADA system, you go to your HMI. Is it reading incorrectly? And then go verify the condition in the field. Get whatever documentation you can on the device before you go out and look at it, unless it's a device that you know very intimately. It's something you already have familiarity with. The most likely cause of a lot of instrumentation problems is power, right? So you lose a power supply, or maybe a fuse blows or something. Check power that you've got to the instrument. Then inspecting wiring and check the PLC input. Make sure that there's no loose connections. The PLC input signal will normally be checked by an integrator, I would think, but it's something that I've been able to talk operators through in the past over the phone. So it's something that that's the sort of thing that if you have an integrator on site, it's good to have them teach some of those troubleshooting components to be able to say, this is how you'd check the signal on a level transmitter, and you can take this wire off and stick your meter here. But to be able to give you guys some more tools to be able to support that. Go out to the sensor itself, obviously, see if it's got, especially if they have a display on them, is it reading at the sensor and not reading at SCADA or at the PLC? But if it's dead out there and you've got power to it, then you've got a bad sensor. check calibration on it. Maybe it's something that is reading out there and is just reading wrong into the SCADA system. And verify that this is basically, it's kind of a duplicate. Verify that the computer interface is working correctly and that the PLC is reading the signal. And then if you get it back online, obviously, it's really critical that you test it, right? Especially with instrumentation. Make sure that what it is, if it's reading on the system again, make sure it matches what you're actually seeing in the field. Especially if they've got if you have a display on the device, make sure if it's a level transmitter, it's reading the same on SCADA as it is on the device itself. And then once it's done, it's really important to record what it is you did to get it fixed, so that the next time it happens, it's good to either keep a logbook or maybe even just send an email to other people within the organization, just so that the next time it happens, it can get resolved more quickly, hopefully. This is an overview of a typical control panel and just PLC panel of what some of the typical components are in it. And I'm not sure what level of involvement you guys get with this, but it's for an integrator, if we get a call, it's really, really nice for us to be able to say, is the power supply working? And so like just being able to recognize some of the components can be really helpful. You can see like in this panel, network switch, it has all the network connections for all the devices that are connected in the building. Normally for every plug that's plugged into that switch, there's an LED light next to the port that tells you the status of that device. So that's something that it can be really helpful to be able to say, hey, do you see lights next to every device that's plugged in there? And if you don't see a light, then we have some documentation to say, hey, you could say port 8 has something plugged into it, it's not lit up, so we can tell what device it is that has failed. The PLC, the programmable logic controller, that's what does all of the logic for the panel. It's making all the decision making. It's running all the sequences to tell things when to start and when to stop. The main thing on that is to be able to just understand, just be able to see it. They've got indicators on those devices to know that to basically check the health of it, right? There's fault lights on all the I/O cards. There's fault lights on the processor. Make sure that things are currently running. There's a run light on the processor to be able to diagnose that. Circuit protection, circuit breakers, be able to diagnose if a circuit breaker's tripped out. Obviously, that's a really quick find inside a control cabinet. But normally, if something's tripped, right, it's almost never a bad breaker. Something else has caused that thing to trip. So I hate to just flip things back on and walk away, but that at least sends you down the right path. And then this device down in the middle of the cabinet is the 24-volt power supply. That's what kind of powers up all the automation components, and that's a really typical item to fail in a PLC cabinet. Another item to fail is uninterruptible power supply units, UPSs. And that has, basically that's the battery backup. So if you lose power to the cabinet, that UPS is supposed to take over and kind of like weather the power outage. And you can see in this cabinet, you have generally install these with like dual plugs for the UPS. So if the UPS is to fail, you can actually just take a plug out of one port and just stick it in the other, and you can bypass the UPS. A UPS is also a really typical component to fail, and it's unfortunate because it's supposed to be the component that saves you during power outages, and it takes you out during normal power. So, and that's, yeah. And that's, I had a separate slide on here, a note on UPSs. A lot of places will designate, we need to have 6 hours of backup power on our UPS to keep a PLC running. Well, when you lose power to your site, you've lost all your valves, you've lost all your pumps, you can't do anything. The only thing a UPS is going to be able to do is provide maybe so that you can see instrumentation, right? You can see what, levels and see what's going on, but you're still not going to be able to control anything. in my mind, you want to be able to protect electronics with a UPS in case you have brownouts or whatever. But it's important that because they fail so much, it's easy to swap them. So like I said before, make sure that your UPSs on your control stuff have either the swappable plugs, and what we've actually started to do in some of our newer control systems is we install a relay in the panel so that if the UPS power fails and the line power is still on, it automatically bypasses the UPS and then lets you know. And we've actually, in the ones that we've installed, you can go out and you can hit the power on the UPS and you don't lose power to anything inside the cabinet. It just switches over to line power. So we talked about motors, instrumentation, and kind of the general, some general PLC stuff. HMI is not working is another typical problem. I think that's something that is normally going to be something you're going to call an integrator on. It's going to be something that has to do with networking or, or a failed component. But I guess I'd like to, and this is just a slide that kind of just reiterates the things that we talked about. Electrician's going to be power distribution problems, replacement of devices. I think doing the actual repair and repair of bad field wiring. An integrator is going to be the diagnostic stuff, instrumentation, and I would consider the integrator to be the default to call first. If you have a problem, you have no idea where the source is, an integrator is probably going to get there faster as far as being able to identify it. The other advantage to having an integrator do it is to provide remote access to your site so that you can, if networks are still working and we can get into a PLC, we can normally identify problems without having to make the trip on site and be able to say, hey, you've got a pressure switch that's bad on this pump. So there's a lot of value in that from a cost perspective as well. And then IT, in my opinion, you want to call them if you're just having trouble getting into the system from outside, but that would be and if you're having problems on the administrative network with seeing the SCADA system. So it's feedback so far. Do you guys have anything to throw out there to say these are the things that you'd like advice on or feedback on?
What about a VFD stop? If you're having issues with codes on VFDs or programming on VFDs, who do you call?
I would say typically if it looks like it depends on the fault that you're getting. If you're getting over voltage faults, or you seeing like the VFD is saying overloads on the motor, or it's showing like a short, something that would indicate like a bad motor, then that would be something that you would probably just call an electrician out. But if it looks like it's a control problem where it's not seeing a signal come into it, it's probably better off calling an integrator for it. So, but if you have a relationship with an integrator for your site, it's, in my opinion, you might as well make the call to the integrator and say, hey, I'm getting this fault. And they're probably going to be able to give you the advice to say, oh, I'm probably not going to be able to fix that, or it's probably going to be a replacement VFD. So, and like I said, anything over 10 horsepower, I'd be calling an electrician to replace it. And anything smaller, I think an integrator can pretty easily take care of. Richard?
One of the nice things is that, especially you get called out, 3 o'clock in the morning, you get a call, you got an alarm, call. You kind of know ahead of time what you're going to bring to that site.
Right.
We had one on Sunday, we lost phases. Motor ain't gonna start without all 3 phases. Like we knew where we were going to right from the get-go. So it makes it a lot simpler than you're going to diagnose a problem. You get your high water and stuff that,
Right.
or your generator didn't start.
Right. To get your notification systems and.
You kind of know ahead of time when you're driving in, like, okay, I'm going to need 2 more people, or I'm going to lead electrician, or I gotta get hold of Steve
Right.
or somebody to help.
And that's a really
It
good
started
point.
a lot easier from when I started out, kind of how you guys, oh boy, what am I going into now? So, I mean, our system is different than a lot of people.
Well, and everybody's kind of got the same. Everyone's just got their own idiosyncrasies. So, but yeah, that's a really good point. Is some of the tools that SCADA and notifications are able to give you can help really to identify a lot of these things yourselves. And I'm going to try to blow through some of I've got a couple other sections here that I just want to run through with you guys. I'll move more quickly. So, and this is to discuss more of the, maintaining your system, to make sure that some of these things, some of the bases are covered, to make sure that you're prepared to be able to respond to issues as well. But documentation to keep, make sure you have drawings of all of your equipment, bill of materials for any equipment that comes through, just like we talked about for the OEM stuff before. Make sure you have backups of your PLC and HMIs. If you don't have backups, you lose your PLC, you're done. It could be, you're starting from scratch and rewriting things. So hopefully, if you have a relationship with an integrator, they're kind of keeping this stuff for you. Operations manuals, device listings, lists of all the PLCs that you have on site, network listings, especially if you've got IT guys that are going to be involved at all. It's really important that you have good documentation of everything that you have from a network perspective, because that can walk on top of some of the other stuff. I will say, personally, I've had at a customer site, as a water treatment plant, the entire Slaker building brought down because they didn't have segregated networks, and somebody plugged a printer in, and it gave the same IP address as the Slaker system, and you lost your Lime system for your water plant. So, and then documentation of device and system settings. Spare parts to keep on hand. I'm sure you guys are always. It's an uphill battle all the time, right? Because you got to spend money to have spares, but really doing some analysis of what are the critical items in your process. So, number one, what are the critical processes? These are the processes that can't go down, and in those processes, are there single points of failure that you don't have backups for? And those are the things that you need to have. Make sure that you have some spares, and also look at. It's something that wasn't an issue 2 years ago, but what are items that aren't readily available? We're seeing regularly, I was just talking to Brandy about this earlier, we're seeing regularly 14-month lead times on PLC processors and PLC cards. It's a different world. Things just don't happen quickly, and you can't get parts, so it's something that really has to be taken into account. And then, doing some of the criticality analysis and kind of rating your equipment and your different processes to say, all right, well, these are the different areas that we really need to make sure that we've got good backups for. Other factors and decisions for obtaining parts, obsolescence. I don't know if anyone who's running like a Slick 500 PLC in their process, those are no longer supported by Allen Bradley as of September this year. So it's going to be an eBay item. I would suggest if you keep those in your facility, you need to have spare parts on the shelf, because at some point it's going to be difficult to obtain. Look at standardization of parts so that obviously you try to use the same things in many places as possible. And then also look at shelf life of parts. And I don't know if this is really well known, but what I've been told by some of our vendors is that a VFD that is sitting on the shelf has less of a lifespan than the VFD that's in service, because the capacitors on a VFD need to be charged. So putting a VFD on the shelf and you think you've got a good part that's sitting there in case this thing ever burns out, there's actually a really good chance that you're going to go to install that and it's going to pop as soon as you put it in. Certain instrumentation, I think like DO analyzers and such, you don't want to, I think, have shelf lives of that. And then also UPSs as well. They're thorn in my side. But UPS batteries, don't keep backups of your UPSs sitting on a shelf, because they're going to be bad by the time you need them. I'm going to kind of blow through some of this, but this presentation will be available. But this is just kind of some recommendations for periodic maintenance on all of your systems. I think this is for control cabinets, making sure that you're keeping backups of PLC programs, checking and cleaning air filters, make sure that things aren't running too hot. But the highlighted item on here, the H2S infiltration, that's something really to make sure you're, especially at wastewater plants, to make sure you're watching for. And you get hydrogen sulfide inside panels. I don't know how many of you dealt with it, but I've had entire systems fail because of hydrogen sulfide. And basically, the indicator of hydrogen sulfide, if you guys don't know this, is anything that's inside a panel that is copper will turn black. And the more hydrogens, and over time, it'll turn brittle, and then actually it destroys all the electronic components, all the copper wiring inside the panel. So that's something definitely to watch out for. If you have hydrogen sulfide infiltration, there are corrosion inhibitors that you can use, but the best solution is adequate ventilation. So looking at the way that you're ventilating your control cabinets. PCs and servers, this is best to be probably done by an IT or an integration group, but making sure you're keeping backups of all your SCADA stuff. Make sure you're keeping things clean and making sure that the computers are all running in a reasonable manner. And then administration and security. I think this is also, it's more of an IT function. And I think the systems integration should be involved with this, but to make sure you're auditing that if someone leaves the plant, that a user gets removed, right? Like you don't make sure that basically that there are some security guidelines that are published governmentally that basically say in a water and wastewater plant, you should be checking to make sure that not only is the cybersecurity taken care of, but things are physically secured as well. So you can't have somebody come in and wreak havoc. And at one time, it kind of seemed like Chicken Little stuff, but there's been real instances where plants have been affected by breaches. So the last thing I wanted to talk about was utilizing your SCADA system for troubleshooting and how you can really optimize it. Obviously, the most obvious use of it is to be able to just monitor what your equipment's doing, right? You have a problem in your process, monitor on SCADA. You should be able to see the status of instrumentation and equipment in your facility. One thing that's really important on your SCADA screens is that to look at how these things are designed. It doesn't really show that well on the screen, but to look at your use of color and the way things are depicted. This screen has all sorts of different colors and different not really good indicators on it. If something's wrong in a process like this, you can't really tell that there's something wrong. It's not immediately and intuitively obvious. It's more important just to kind of keep things simple and use standard colors across your system. This is a much better representation. I actually prefer, like on this system, I don't know if you can see it, but red is off and green is on. I prefer for anything in a SCADA system that's red to be a problem, so that you go on any screen, you see something that's red, it should get your attention. It should tell you that there's a problem in this area. Using the alarming systems, obviously through SCADA, I think Rich, like you were talking before, SCADA has a lot of capability to be able to tell you a lot of information about your process. And especially now that, even down to the VFD levels and like down to instrumentation, they'll have field buses and networks that can pull a lot of information off of it. So they can tell you exactly what the fault is. And so it's important to pull all that data into the SCADA system so that that can help you. Looking at trending data, you can see data within the process. That is extremely useful to be able to see how the process is running, but also it tells you when things have gone wrong as well, to be able to see, is it a process that's degraded over time, or did something just have a failure instantly? Another use for the SCADA systems is to be able to monitor your network. So you could spend a lot of time trying to chase if there's a communications problem, but if you have a screen like this on your SCADA system, it's super useful. You lose a switch in a building and it tells you exactly where you've lost the communications at. So it's another helpful tool to be able to identify network issues. And then the last thing I had for SCADA tools was integrating O&M manuals into the systems. And I'm not sure how many of you guys have anything like this, but it's really, really nice if you have a screen out in a building to be able to say, you know, you have a pump and you can click on the help screen and you can bring up the drawings for it. Or you can bring up an operations manual on a piece of equipment right through your SCADA system. So it's just the SCADA system is generally more accessible than going back to your desk and bringing up a web browser and finding the documentation. So if you're going to try to organize and keep all of it, it's a really great place to be able to visualize it. So, yeah, I guess any other feedback thus far? Good. Well, the last thing I had, and this will be very quick, this is just a concept that's, I'm sure you guys have probably heard with the advent of AI, artificial intelligence. Very soon, it's going to be a great tool for anyone to be able to use, and it's going to obviously threaten people's livelihood like mine, because AI is the ability of it to be able to help you in technical situations is really phenomenal. And so, yeah, I had this is, I don't know if you guys have seen this before, but this is just a video from a company called Boston Dynamics. This is the ability of not just robotics that you have now, but the ability of devices like this to be able to make decisions. And so you can see what this thing's able to do. The guy calls for it to bring up his tool bag, and this isn't like a pre-programmed algorithm that this thing has. It says it's having to make all these decisions. And so you can see how it goes out and gets the tool bag, goes up and brings it to the guy, throws it up there. There's a lot of manipulation. It had to be able to make a lot of decisions and be able to navigate, real world. Well, there you go. That's the end of it. So, but the point here is for guys like you guys, some of these tools, ChatGPT and Google Bard, are two of the big names right now. There's going to be a lot more of them that are coming out, but it's actually something good to get familiarized with. And it's just a website. You can interact with it. You ask it a question, and it'll give you an answer. So I will say that this is an example of something that I did with ChatGPT, and it said, help me troubleshoot a peristaltic chemical dosing pump that is turning, but it's not dosing any chemical. And this is the response that it gave me. So it's not just like look up a manual and it gives you information doing a web search. It says, check the tubing. It gives you a bunch, the tubing, and gives you a description of what could be causing it. Verify the suction line, confirm the priming, check the pump speed, review the pump settings, inspect the motor and drive, check the power supply to verify that the pump's receiving adequate power. These are really, really powerful tools. And this is like at the ground floor, right? And so it's just, I want to make sure it's something that I put out there. I think it's really important for people to understand it's coming, and it's a good thing to get familiarized with. And it's something that's going to give everyone a lot of capabilities that they may not have, that you don't currently have, right? And I will say, like, even from a programming perspective, I've gone out to these things and said, write me a program that will PID control a wet well and give me that has a lead and a lag pump. And this thing spits back a program that does that. It's scary and amazing at the same time. So, other side of that coin, I will say there's still a long way to go with AI. So I will say a good portion of this presentation I actually created with some of the with some feedback from some AI tools. But I did request create a presentation on troubleshooting pumps in a wastewater plant, and this is the response that it gave me. So it's not all the way there yet, but we're on our way. Conclusions. I hope this was helpful to you guys. Like I said before, I would appreciate any feedback that you guys can provide. If I have email addresses, I'll send out a request for, and in that request, just say any feedback for the presentation. And if you guys, obviously, we're a systems integrator. If there's any interest in us performing any help at your sites, we'd be interested in accommodating that as well. So thank you guys very much for your time and your attention.
We're going to take a quick break. We'll be back in 2 or 3 minutes.
I don't know if that was good or bad, but I did it. People do it. Every day.
So you guys, I'm gonna go ahead and make a correction. It doesn't need to be on the YouTube thing necessarily, right? I don't need to be out there in cyberspace. So today we have Troy Shelton who's with us, and Alex Watson is going to be joining us remotely. And they are going to present, there was GWF measurement systems, and they will be presenting on metering technologies. So welcome, thank you so much for coming, we appreciate having you.
Thank you for letting me come in and let Alex and I do a presentation for you guys. I just started with GWF not too long ago, and things are really starting to roll in the United States with us. Alex is my boss. He kind of brings the operation. I'm the beauty of the operation, unfortunately for you guys. Oh, all right. Thank you. So if you guys have any questions, please raise your hand, holler out. Alex has a deep hillbilly southern drawl, and it's very hard to understand him. So Alex, please talk slowly. Don't get ahead of us, all right? Go ahead, Alex. I'll let you go.
Okay, well, thank you all for I'm very mindful that I don't want to just give you the next product presentation, so I want to give you a flavour of some of the things that we see changing within the measurement industry. So what am I going to speak to today? I'm going to give a quick introduction to me and talk about some different applications. Firstly, pressurised pipes, and then large pressurised pipes. Then we'll jump across to large open channels, and then we'll go back down in size to small open channels, maybe partially filled pipes as well. Then talk about some of the things that we're seeing with the transmitter technologies as well, not only for connectivity, but also how can we make your lives easier from a point of view of improved support. And then finally, I want to just talk through a custom application that we've done so that, you know, there is no one size fits all. There's lots of great technologies out there for doing different applications. And there's also sometimes when people come across measurement needs where they feel that they can't actually achieve what they need. And I think that I'll give you a flavour of something to show how, you know, we can turn technology upside down literally and use it to be able to measure something that people never thought they could. So getting straight into it, GWF. Who are GWF? GWF has actually been going since 1899. Their head office is in Lucerne, Switzerland, where, as Troy mentioned, I have a southern drawl. I'm actually in the 8th office that is noted there. We've actually recently got a 9th site in Austria. 8th site is Ocala, Florida. And you can tell by the Orlando accent that that's where I'm based. However, right this week I'm currently in Lucerne, Switzerland, and have been working in that rather lovely building that you can see there. We've been going for some time. You've probably never heard of us, but yet most of you have probably seen a product, a water meter out there with some of our technology in it. So you can see at the bottom, you can actually see a roller bank that looks familiar if you take apart a water meter, encoded water meter. GWF actually developed the light pipe technology that is used by several major manufacturers like Badger, Mueller, Neptune, has previously been used by Census as well. We've got over 250 employees globally, and we've been active in various areas of the industry: water, gas, electric, and heat metering. The role of GWF USA is on the measurement technology for pressurized pipes and open channel type measurements. My background, I've been in the industry now for 26 years. I joined what was the ABB Kent Meters business that turned into Elster Amco, and then more recently Honeywell. I haven't been with them for a couple of years. I've known GWF for some time, and when they came knocking, it was too great an opportunity to join, especially around some of the technologies they've been developing. So that's me, that's GWF. And if anyone wants to know what GWF stands for, it actually stands for Gas- und Wassermesserfabrik, which is gas and water meter fabrication. That was what they were originally started as, but now more of a technology developer. So let's talk about some of the applications. Pressurized pipe applications. Most of you will have been using and still use and are very happy with, mag meters. They've been a fantastic technology. They've been developed and they're continuously being developed. We're seeing some good changes where people are adding in additional sensors, upgraded electronics, removing grounding rings, and they're very likely to continue to improve. But they do have some, like all technologies, they do have some level of weakness. If you read the instruction manual, there should be upstream, downstream conditions that these things should have, straight pipes and so on. And that will get better and better. And likewise with ultrasonic meters, we've seen more offerings recently being introduced, but often with fixes for technology weaknesses. So you'll see flow straightening vanes, for instance, as an example. We're seeing continued developments on both technologies, but I'm going to give you an overview of some improvements that are getting done to the ultrasonic meters, including, say, the time reverse acoustics, and why these things are making a difference. So what is time reversed acoustics? When a ultrasonic meter is made, generally they are built and calibrations done based on timing of signals going from one side to another. In production, what happens with these devices now is they send a pulse through the water and we get a specific signal. So generally in the past, people would look for a threshold. When the signal went above a certain threshold, they would look to say, okay, we know that we've received it. But instead, what's going on now is you're seeing more of the DNA of the meter. They're actually taking an image of what that signal is, putting it in memory. And each meter is slightly different. So by taking this fingerprint, this DNA, it allows the product to start ignoring things such as material and assembly tolerances, and also upstream, downstream conditions, because we're not looking at impacts to when the signal gets there. We're able to look physically at the shape of the signal. Now, when we've got this fingerprint, when you put this meter then in the field, the reference signal is sent out and it goes across and back across the channel, and it gets sent back through, from one side to the other. So it goes up with the flow and back against the flow. But rather than looking at a threshold as to when we start seeing the signal, we're actually instead looking at the signal itself and comparing it. So we're actually looking for the time shift between them. And by doing this, we're able to avoid more noise, because we can detect the amplitude more easier in both directions. And because of this, looking at that time shift, we can actually start looking at a much higher resolution as to the flow velocity and how that flow can be calculated. This will effectively remove the need for upstream, downstream conditions. We're able to, in fact, we jumped over a slide, unfortunately. Let me see if I can bring this up here. So what this allows for is being able to remove the need for upstream, downstream conditions, especially with more paths. So we're seeing more paths being used in mag flow meters, and we're also seeing that more and more in ultrasonic measurement as well. With that time reverse acoustics, we're able to give far better range. So we can start looking at leakage or otherwise, and being able to understand what's going on. Obviously with these things, if we're looking more at powered devices, so this isn't battery powered, this isn't a billing meter, this is a water management tool. And as well, if we're looking at that DNA, that fingerprint, we're able to actually look for verification of signal behavior. So if there's an issue, we can see it, we can see that change, and we can raise an alarm. So these products are getting more and more intelligent. We're able to avoid the need for expensive calibration, field verification visits by being able to look at that DNA, that fingerprint automatically. So that's something on time reverse acoustics. Very good for measurement of flow, final effluent, raw water applications, clean water applications. If it's wastewater, then MagFlow can still be good, but we're going to look at an alternative technology to that in a short while. Now, going on to the larger sizes, say 12-inch or above 12-inch, it could be an inline meter very easily, or depending on your applications, there's a lot of products out there that allow for tailoring towards specific requirements. If you're needing really high accuracy, or you've got really harsh installation conditions, or you've got maybe the need to measure wastewater in a force main application, or if there's safety aspects for maintenance of a mag, say a mag meter or a inline meter, being able to look at different technologies, whether it be clamp-on or insertion type devices, these types of products can be tailored to suit the needs. So I'm actually showing various methods of measuring. Some of these products, when I talk about large diameter pipes, some of these products can go up to 30 feet in diameter. So we're not talking just 36 inches or maybe a little bit higher. Some of these technologies can go very, very large. Now, not everyone needs something that large, but things are able to do it. Depending on applications, we can look at various things, whether it be an insertion type device and we're creating cross planes within the flow, or whether it be a clamp-on system where we're creating cross paths as well, or an internal mount. Depending on your application, these products can be tuned and tailored to exactly meet your needs. So it's not like a case of you have to accept a product even if it's not right. There's options out there to be able to make sure you're measuring accurately. What does this mean? So when you start putting more and more sensors, these are insertion sensors providing what you can see as cross paths in a layered method. The more and more paths we put in there, the more and more accuracy that we can get. This is all time of flight technology, so very, very assured, very long-standing technology. We can accurately determine, manufacturers can accurately determine the distance between the transducers when they're installed. So all we have to do for calibration is make sure that the signal frequency is staying on track. So keeping these accurate is very, very easy. The fact that we can put multiple paths in here, although that looks like a bit of a school science project with lots of pipes coming out of it, this type of application, we can measure, less than 1%, maybe 0.5% accuracy on a very large pipe. So allowing you to be sure that if you're looking at custody transfer, or if you're looking at wastewater measurement from a large commercial client or other applications, we can measure it very, very accurately, or we can reduce some of the paths if the accuracy is not, or the high accuracy is not completely required. Again, by having more and more measurements in there, we can deal with those very tight upstream, downstream conditions by being able to average the flow going through the system. By having more transducers, and also the larger the pipe, as you get larger and larger, we get a better signal to noise ratio, because we have a longer distance between the sensors, which means that we can be more accurate over a wider range, especially where there's low flows required. We can ignore background interference by having good signal to noise performance. So taking that idea of multi-path, multi-layer type applications, we can actually take that and use it instead in looking at, say, a channel flow measurement or tunnel flow measurement. So again, transit time, we're sending signals from one side to another. We're creating planes or layers of two-path measurement, so that we can accurately measure through say a channel or a canal or a tunnel. These types of applications, whether it be a raw water intake, we've actually seen in Mexico City, they've recently installed a similar system with 3 layers to be able to measure their raw water intake into their largest treatment plant that they have for the city. You can use it for stormwater channels. You can use it for combined sewer overflows. So where the media is very fluid, these types of systems are extremely useful. And because we're averaging across both of the paths and between the planes, we can actually cope better with the turbulence within the channel. So if you think about it, when you've got a cross path, if there's flow going from right to left in that channel or left to right, we're able to pick that up and average that out, so we can take into account again upstream, downstream conditions or any kind of disturbances. So that's larger type applications, but also how does that cope with smaller channels? So these types of systems are good down to say a 5-6 foot wide channel, but if you go smaller than that, or say you want to go into a manhole and look at, say, a gravity sewer, what can you do to measure that? So when it comes to these types of things, there's 2 ways of being able to measure, either with non-contact type systems, Doppler systems like laser or radar, or we'll go on to wetted sensors in a minute. The non-contact are very, very good, especially where access to the flow is not possible, or for instance, if you've got a lot of heavily polluted media, such as raw sewage, you've got maybe a lot of rags in there that could maybe cause problems for the wetted sensor. So using something like radars, they're very good in the fact that they're unaffected by temperature or surface foam. So if there's foam coming through there, we can still measure very accurately within the system. These types of things, very good for many applications, whether it be wastewater, inlet flows, stormwater, fine lead effluent, trade effluent, or even just C&I type waste monitoring as well. Now, how do these measure? If in reality these are measuring a point. So on the right here, you'll see a graph of a channel. When you're measuring in a point, so we're showing some dots that would relate to the point of where it's measuring. If you just measure that point and convert that, assuming everything's flowing at the same rates, you'll be quite wrong. So when we put these in, these types of sensors, they have to be calibrated. We calibrate ours by actually defining what the shape of the channel is, and based on the surface velocity that we measure in that one point, and also a level sensor, we're able to then accurately calibrate for what's going on within the channel. So we're actually calculating where there's going to be slow flow, where there's going to be fast flow, and how it's going to relate throughout the cross section of the channel. By doing this, we don't need any kind of special construction work, we don't need a flume, we don't need a weir, so it's a very low installation cost for the setup. And because we know that no channels are the same, many of the vendors out there, will allow for a definition, a user-definable channel profile. So some of the things that are good here is contactless. It's very low maintenance. You're not having to clean a sensor, but at the same time we're having to correct for the fact that we're taking a spot measurement. Now, there is a challenge that if, say, you had a surcharge event, maybe you had a inflow causing the sewer to go up the manhole, the actual level of the water to go up and beyond, say, the radar velocity sensor, that could actually then cause a problem, because if it's then covered in rags, it might not measure. If the level sensor is actually located further up within the manhole, that allows us to be able to maybe avoid the issue of the sensor getting covered in rags and otherwise. And the systems these days can actually switch using a replacement function. So if there's a problem with the velocity measure, we can turn the system into a flow measure using, say, a Manning equation on just the level until such a point that the velocity sensor can be cleaned. So these things have been designed in to allow for continual measurement, even if there's maybe some challenges. And if there is an issue, we'll talk in a minute about the capabilities of these transmitters, being able to tell you that there's a problem, so you can go and manage any kind of cleaning or maintenance as required. So what happens if you don't quite have the heavily polluted media? What other options are there? There's several area velocity sensors out there. So using Doppler technology, they're able to look at the velocity of the flow, and also many of them have a built-in level sensor, or have the capability to allow an external level sensor to be used as well. Some systems even allow both, so you have a backup. What does this mean? This means that if there's an issue, or the situation is that the flow's in a very large channel and you reach the limit of the built-in level sensor, it will switch across to an external one, keep measuring. However, the challenge with these types of sensors are obviously if it's wetted, if there's a potential for catching of rags around the sensor, you've got maybe a maintenance issue, at which point non-contact may be better. But if you're not looking at that, then these types of sensors can be either installed in the bottom of a pipe or channel where access is available, or even underneath the channel, so an insertion type into the bottom of a pipe. That way, if there is any kind of rags or otherwise, an insertion device, they're often designed to be flush with the surface of the pipe, which means that you won't capture those rags. You'll still be able to measure and reduce the needs for cleaning and maintenance. And often, there's always the challenge of silt and debris collecting around in the bottom of the channel. Some of these sensors and devices are now even capable of being offset so that they're actually mounted away from a vertical position. So any silt will collect next to it and not on top of it as well, meaning, again, less maintenance needs for crews to go out and clean these off. Now, what about improvements in sensing for these? Many of these systems are often using a continuous Doppler measurement. More recently, we're seeing a move towards pulse wave Doppler systems, where the system sends out a pulse of acoustic signal, and that is received back after it bounces off of different particles within the water. Now, what is interesting about this is you're able to listen at different times for that received reply where it echoes back from a particle in the channel. Why is that important? Well, if we're listening at different times for that echo, you can actually start to find out what's going on at different points within the channel. So suddenly we're able to say, okay, we can break the channel into multiple areas and be able to calculate or measure the velocity of the flow at different points within the channel. That's important. So I mentioned with the radar that you're doing a spot measurement. You're only measuring the velocity at that point, and we have to correct for how the flow will be going through the rest of the cross-section of the channel. But by measuring different points within the channel, we're able to actually see a flow velocity profile for the channel. So on the right here, we actually have a graph where you're seeing different heights within the channel. We're seeing different velocities. And I'll show a different example of this in a short while. So this means that we don't need to calibrate on site. We can tell the systems that, hey, what the shape of the channel is, but we're actually then starting to track particle movement and actually measure velocity profile and not just one point within the medium. Now, by doing all of this, and we collect all of this, what can we do with these systems? So let's get pulled into a transmitter, whether it be ours or someone else's, but we're seeing a lot of capabilities being put into these systems. Often multiple communication options, all provided as standard. So whether it be serial, Modbus, wireless, cellular, Ethernet, all of these ways of communicating with the device means that data is more accessible for you, and also potentially service is more easier for you too. They also can take in extra inputs. So a lot of systems will take in extra 4 to 20 milliamps or digital devices. What's the benefit of this? Well, if you're able to start monitoring additional 4 to 20 milliamp sensors, you could be putting in a temperature sensor in a manhole, and if you see a drop in temperature, you could well be looking at an inflow or infiltration issue. Or you could be monitoring pH or other factors to be able to see if there's a problem or change during normal operation. Outputs, again, you could potentially be providing multiple 4 to 20 milliamp outputs for SCADA, maybe relay output for being able to turn on and off an actuator, or even pulse into another system. These systems also have built-in data loggers, so guess what? If there's a problem, download the data. It helps us see what is happening within the device. From a service point of view, being able to capture that data is very important for us to be able to see if there is an issue or what may be going on where there's a concern. And also some of these systems have wireless readouts. So I know that ours have built-in Wi-Fi routers, which means you can use a tablet, go up to the system and be able to log in as a tech and be able to pull data without having to unplug things, without having to try and change the settings of the system. You can do it straight there and then right on top of it. So by having lots of options, using these devices these days means that you can potentially use existing communication hardware or methods. You might not need to upgrade SCADA systems for a new device. Having more inputs, as I mentioned, allow you to look for more sensors to be monitored from one device. And now the thing which I find most interesting and often turned down by utilities is the ability to connect these devices to, say, a 4G cellular network, which allows monitoring in various ways. It will allow us to be able to help tell you if there's a need for cleaning, maintenance, or even manage if a replacement function. So if a sensor has stopped and it's changed how it's measuring, being able to manage that remotely again becomes very powerful. What else can being online help with? Well, metadata visualization, being able to get the data into a cloud means that you can start looking at it. This is in addition, or if you're not using SCADA, this gives you the ability to look at that data from your desk, not have to go out and read it. If you're using SCADA, this may not be needed, so it's not something you have to have, but it's something that can be very useful. So we can look at locations, we can look at dashboards for the device, we can look at the data for the device, we can provide reports very easily. So these sorts of things, often software as a service, if you don't need it, you don't pay for it. You use it, you pay for what you need, and it also allows you to be able to help push data elsewhere if you need it to as well through APIs. So being able to collect the data and look at it is great for the customer. But what if there's a problem? What if something happens in the field or something's going on which is a little bit strange? So having it connected, providing that connectivity through a secure link gives a lot of options. Imagine rather than calling out a field tech to go and visit, and there's maybe a flight cost, a hotel room, a rental car cost. Investigation can happen without that field visit. Direct access to the system data allows us to look at various things. So on the left is just looking at each of the signals within the device. We can do that remotely. We can look at the parameters, check to see if there's anything wrong. We can even look to see if there's maybe changes for the digital signal processing settings, lots of things. And on the right is actually two graphs that have come from a system where noise was being seen. This is a system that is being used as a combined sewer overflow that is being used to control chlorine injection. Now, obviously, you see a lot of noise here that could cause that injection system some challenge, depending on how it's averaged. But when looking at it, there was one of the paths. There was multiple paths in the system. One of the paths that appears to have an issue. So by being able to control the system, turn off that path, we've changed the accuracy of the system by about 1/10 of 1%. So very limited impact on accuracy, and yet we're able to now provide a very clean signal, again, without even getting out of the office to go to that site to see what's going on. Now we're in the process of planning in to go to that site to investigate what that issue is at a point when maybe maintenance for the site is underway. So by getting these connected and allowing for service techs to be able to help monitor it and maintain it from a distance can greatly improve what's going on and also avoid any reactionary efforts. Now, I've talked a bit about different technologies and also, some of the features of products that are out there these days. But what about, challenging applications? Does one size fit all? Is there a perfect product for everything? And the answer is no. But I'm going to give you a quick overview of what we've had to do for a wastewater treatment plant influent measurement system. The customer had actually tried a couple of other sensors without success. And the reason being is that obviously the channel media height, so the flow height could change. It happens in a lot of systems. But the challenge really was the fact that the channel depth could change because of excessive silting. So when they were looking with radar and laser sensors, they were actually only looking at the very top of the flow. They weren't actually looking at the change in the cross-sectional area of the channel. So there was no regular solution available. We actually went surfing in their influent channels. We actually created a system that I'll talk a little bit more in a minute about. But yeah, it doesn't look like a standard flow meter, but by looking at this in a different way, we're able to give the client a solution. So what did we do? We actually used area velocity sensors. This is an area velocity sensor, our HOI PSC, which is normally fitted in the bottom of the channel looking upwards, but instead we mounted these on the bottom of the surfboards so that the level sensor was actually measuring down to the level of the silt. So we now are able to measure the height from the top of the flow down to the level of the silt in the bottom of the channel. And then by adding in, so I mentioned earlier, some of these systems are able to take into account the other sensors. We mounted a level sensor above the channel so we could measure the height. So as the surfboard rises up and down, we're able to determine what's going on at the bottom of the channel as well as at the top of the channel and the velocity that's going on. So this allows us to be able to measure that variable orifice within the channel. In addition, there's actually return flows coming up into the inlet of the treatment plant, and by adding in a couple of insertion sensors, we were able to take that into account and be able to correct for that, so that so we were able to deduct that, so we were able to accurately and with an independent certification as well meet environmental regulation by accurately measuring the inlet into and the inflow into the treatment plant. We also were able to set up the return path that we were able to do a secondary measurement point as a verification check. So no one had to turn anything off if there was a check in the future. The other thing here is with the if I just jump back slightly, the way that the surfboards were mounted, they're mounted in such a way that a operator can have them raised up so that they can brush anything off in case of issues of ragging or otherwise on the bottom of the boards. The system's able to tell the client that there is also a change in signal strength, so there's maybe the need to clean. So again, it's not reactionary, it's preventative cleaning that can occur. So now that's where it was installed, but let's talk a little bit about that velocity flow profiling. So obtaining an accurate velocity flow profile was very key to the high accuracy that was needed. The sensors that were installed have the ability to measure up to 32 cells within that flow channel. Now, depending on the level of the silt and the level of the water, we may get 32 channels or we may get less. But this is actual data from one of those flow channels from underneath the surfboards. The surface is at the top, the bottom of the channel is at the bottom, and we've got three different data points that we can show, and you can see that the velocities are different depending on where you are measuring within the channel. The radar and the laser sensors that were tried before are only measuring at the very top, and you can see that there's higher velocities towards the bottom, which mean that any of those point contact measurements were likely to be quite wrong, and we calculated about 40% in uncertainty based on a spot measurement at the top of this flow. So by being able to not only measure where the bottom of the channel was, where the silt was, and where the surface was, and the velocity, we were able to provide a very accurate flow measurement for this particular client. And again, it wasn't something that we could just pick off the shelf. We had to work around the application itself. So that brings me to the end of what I've got to say. Hopefully you've got an indication that there's a lot of changes happening within technologies. There will continue to be a lot of changes happening within these technologies. I think the important point out here is depending on your application, there's a lot of things that can be done. So, if there's a challenge that you think you can't measure, bring it to us, because I'm sure that we can look at it, and some of our compatriots at other companies could look at these things and give an indication of how we can measure these things, give you an accurate indication of what's going on in your system, and be able to give you the ability to meet any compliance issues that there may be, or just improve on what is getting done right now. So if there's any questions, please, be happy to answer them to the best that I can. I'd like to thank you for your time for listening to me.
Does anybody have any questions?
Yeah, from the top to the bottom of the flow, yeah. A lot of measurement at the top where people are doing it, but it's asking down here on the bottom, that's the measurement getting people in this.
Yes, when you average between here and all the way down based on the width of the channel and the shape of the channel, compared to a measurement at this particular point, you can see the velocities are a lot higher than the very surface. And when we average those out, we were seeing about 40% inaccuracy between a spot measurement, whether it be a laser sensor, one of our radar sensors, it would have been the wrong thing for that application.
Anybody else? All right, thanks, Alex.
But thank you all for your time. I very much appreciate it. And if you've got any questions, you can give them to Troy. He'll probably start sweating, look like a rabbit staring into headlights, and give me a call.
Thank you very much, Alex.
Everyone awake? Okay, next we have Joe Thomas with the Illinois Department of Labor / OSHA. Are you with both? OSHA, okay. What to expect at an inspection? Have you all had an inspection? Yeah? Was it Department of Labor or was it OSHA that came? Yes. Both? Our last one was probably 7 years ago. It was Illinois Department of Labor, but that's changed now, right? Okay, I will pass this on to you.
What do I need to do with this?
Just clip that on your pocket. Clip this on your shirt.
I don't ever do this type of mic stuff.
I know, right?
I'm a compliance officer, I'm not a speaker.
Clip that close to your mouth. There you go.
This gonna be good?
Now let me know.
Hey, good?
Thank you for coming.
Right, okay. All right. Like I just said, folks, I'm a compliance officer. I don't do a lot of speaking. What to expect? I'm gonna go through. What you're gonna get is like I'm walking in your front door. This is exactly what you're gonna be asked for, what you're gonna see. It's not getting the cat out of the bag or the canary off the post or whatever. I want you people to be safe, so I'm going to tell you exactly the programs and plans you need to put in place. This is what you'll see. I'm a compliance officer, state of Illinois. I've been with OSHA about 3 years. I have a Bachelor of Science degree from the University of Illinois. I have 250 hours of classroom education at OSHA, and I spent 15 years in an oil refinery, and that oil refinery sent me to the hospital. So I believe in what I tell you folks. I'm here as being a part that had to be admitted, okay? So it's OSHA 101. Who are we? This is a slide that we put in all the presentations. Naturally, I'm at the bottom. I'm occupational safety and health. There's 3 offices for almost all the programs and all the stations, whether that's health and human services or whatever. They're in Chicago, Springfield, and Marion. This is our mission. You can read that. I'm not going to sit here and read it to you because my mission is a little bit different than that you're going to read right there. Go ahead and take a minute. What my mission is very simple. If I come and see you folks, I don't want to see you again within a year. And the reason I say that is because if I do, I failed you. You got hurt. Something happened to send me back to your plant, your facility, whatever it is that you have. And the other reason I say it's a year is because most training programs are annual. You got to keep up on stuff. I can't help the person that you bring into your plant that you don't train, okay? Jurisdiction, I forgot your name already, I'm sorry. Right, you, yeah. Brandy, we've changed. Illinois OSHA has jurisdiction over fire departments, police departments, the Illinois State Police, example, we can demand entry there. Water, sewer, universities, anything that's public, anything you pay a tax dollar to, then Illinois OSHA falls over those categories. The private side of things, I'm in Peoria, so I think there's a federal office here in OSHA. Yeah, okay. So if you've got Bob's Welding or a grass cutting service or something, privately, you are going to ask for the Peoria, the feds. Publicly, you're going to ask for Illinois OSHA, okay? Said county sheriff, they're all underneath us. The goal, very simple. I'm a fisherman, I'm a hunter. Hopefully when I retire, I'm going to be able to do both. As I said, I got hurt at a former job, so that's part of what brought me into this. Let's keep all our fingers and our toes and so on and so forth. I don't think anybody's working because they really actually love it. Maybe I'm wrong, I don't know, but I'm not one of them. So, like I said, this is going to be an inspection like you're going to get. So we're going to go straight down the types and everything else. I'm Joe Thomas. I already told you the officer is going to show you the credentials. If they don't have them, you can stop things right there. They only give these badges to certain people. It's not the old sheriff's badge and stuff because that was misused, to be quite honest. People were posing as cops and stuff. We are cops, but we're not cops in the sense of law enforcement in that manner. Anyways, people should show you the credentials. You've got several different types. The PPI is the program planned inspection, which is what most of your inspections will be. That is when the computer kicks you out. I don't know the names of your local areas, whatever. Elkhart, municipal sewer system, whatever. A PPI is kicked out by the computer. It's a random computer selection. A complaint, we do those when an employee complains of unsafe conditions at their facility. Believe it or not, we get a lot of police officer complaints on their management, and we have to go check them out too. It's kind of funny, you think that the people that protect us on an everyday basis would have good squad cars, good tires, good sirens, good lights. They don't necessarily always have those things. So we check out complaints. Fatality, I don't ever want to see you for that. I'm an emotional person. My heart's on my sleeve. I've sat and cried with the people at these inspections. In the case of a fatality, I had to drill a guy. It was his son that got killed, and I got to drill him on OSHA compliance. We're sitting there crying together at the end of it, okay? I mean business in that I want you guys to come in and go home, right? Catastrophe is loss of eyesight, fingers, toes, any type of amputation, something like that. Partial comprehensive, is it a partial inspection to investigate a fatality or a catastrophe, or is it a comprehensive, which is what most of you will probably go through? Comprehensive is we flip your, whatever it is, your plant, your facility upside down. We go through everything. A typical comprehensive inspection for me, depending on the size of an establishment, is 2.5 hours probably. On the low end, average is maybe 4. And I've been up to 2 days at police departments and fire departments. It just depends on how many buildings, tanks, vehicles, whatever. We go through everything. For us to do the inspections, we're going to ask for management. We're going to ask for the facility executor. If you're, say, a fire protection district, we're going to want to have the board president there. We're going to ask for a shop steward if you're union. We're going to ask that you notify the BA that we're on site, so they all have the option to come and attend. But I'm going to stop when the management walks out. I'm going to stop when the frontline worker walks out. We need everybody, because OSHA's not going to entertain the he said, she said. It's not going to happen. Everybody's going to be there. So that's when we set these inspections up, or when we first walk in. One of the first things I say is, folks, we're going to be here 3-4 hours. Please make any notification that you need to make, because we're going to go through everything and we can't stop, basically, is what it comes down to. Interviews, it's a necessary part of every inspection, period. Some of it's done one-on-one. Some of it, if it's my case, I might walk in and just give you a interview questionnaire and you fill it out. That interview information is between me and that person, OSHA and that person. It's not for the boss people. The management's not going to see it. The union BA is not going to see it. The only way that can be released is if an administrative law judge in a court case says you have to release that interview information. I've never known it to happen. So I always ask people to just be honest. And after the fact with those interviews, I get a lot of calls. Like I said, I am a compliance officer. I'm not a speaker. I get a lot of calls that say they're going to kill me, they're going to hurt me. I've had my phone ring 3 times in a half hour from leaving a waterworks facility for a guy that just got off a disability, okay? Interviews are part of it. Handouts, they call me the king of handouts. This is where I want you all to open your folders up, and I'm going to go through what you're going to get. All right, as I don't know what you are, you're sanitation, I guess, but you're public servants. Everybody in this room is allowed all these free services that are in this pamphlet. It's got different information you can call in. Child labor laws, amusement parks and rides, the 1 Day in 7 Rest Act, all of that stuff is in here. Take it, throw it at your plant. If you're representing, I don't know what cities are around here. If you're the representative, throw it down on your conference table so people know it's there. All this stuff is free. It also has the locations of all the IDOL offices. And a big one on here in the middle is OSHA consultations number, okay? You don't have to be part of an inspection to call us. If you've got a question, call. Is it legal? Is it not legal? Is it safe? Is it unsafe? I personally don't care if you work for the state or not. And if you own your own business, call me. I'll help you anyway. That's what all officers should do. But that's a pamphlet you're going to see if I come to your place. So all the officers are different on what they hand out. This is a law that you have it posted at your place of employment, every single employer in the state of Illinois. So when we come into the building, this is one of the first things I'm going to look at, or look for, I should say. If you don't have it, believe it or not, it's an other than serious citation, and you can get a financial penalty for it. You're supposed to have it up. But what it covers, especially for all of us, we're the worker bees. It covers our rights, and then it also covers employer responsibility too, okay, their rights. On this, which you have to have posted, is an excerpt of this. What we hand out here, where is this thing actually coming from? They're right there. Anyway, what this is an excerpt of what's on that first poster I showed you. It is law if you have an inpatient hospitalization, a finger, toe, or some type of amputation, or the loss of an eyesight, a loss of an eye rather, that you call into OSHA within 24 hours. If you have a fatality, which God hope it never happens, you have to call in within 8 hours. But the thing about this, and post this one right next to the other stuff. The thing about this is you're going to get a live person, and I like that instead of the press number 1 for this and all that. You're going to get a live person, and they're going to take down all the information on what happened to that individual. Fell down the stairs, broke a leg, was taken to Peoria Memorial Hospital, physician that treated him, all that type of thing. What's going to happen after that is that information is going to be reviewed by one of 3 people in Chicago or Springfield to see if there's maybe potential employer fault. If that is a potential there in their opinion, then they're going to send out an inspector to do an investigation. I'd say roughly speaking, probably 50% of those calls end up in that. If you're in doubt of anything, always call in and report, though. This is sometimes I talked about I get emotional. I had a hard time at this one, but this is why I chose this to give you. It's a simple 1-page document on how simple safety can be. It doesn't have to be a big 3-ring binder. You don't have to spend 40 hours a week on safety. Here's a simple page of backlifting. Why do I get emotional? Because there's one of our brothers and sisters in the last 2 years that is no longer walking because they lifted up a 20-pound box the wrong way. Twisted his spinal cord, snapped, he's paralyzed. And I don't know if there's one in here, but what he was lifting was a box of office paper. And actually, ironically enough, since I'm doing sanitary, it was at a sanitary plant. They were moving office records. So safety can be simple, but it's important. You know, my back's messed up from lifting the wrong way. But again, there's a 24-year-old kid that ain't walking because he lifted something up the wrong way, okay? I believe in giving it right to the heart, just like I just did. This is a live example of one of your direct brothers and sisters. This is the actual report that happened down south a couple of years ago, not quite 3 years ago, of one of the operators at a sanitary plant died. They died on a Sunday. By themselves, don't work by yourself unless you have to. Get somebody, let somebody know what's going on. Here's exactly, like I said, this is the scenario. It wasn't my inspection, but looking through the photos, what still to this day I remember is that the man had a shovel in his hand, and when you look down into the tank, you see the shovel, but the body's gone. It still bothers me. The first people that got to the plant, the man's hat was still floating on the top of the basin. This stuff's real, and this is an exact example of, like I said, one of your direct brothers or sisters that went down in the last 2 years, 2.5 years. I always make my inspections informative. I'm not going to come in and sit here and go, you did this wrong, you did this wrong, you did this wrong. So I hand out this stuff. I want them to be teaching examples. I'm not going to say anything in this room that I wouldn't say at your facility. OSHA's rights. This is what gives OSHA the right to come in at any time unannounced and demand an inspection. And that it's any public employer in the state. As I said earlier, that includes the Illinois State Police. If I want to knock on the door in Springfield and demand entry, they have to let me in. Everybody is simply entitled to a healthy and safe workplace, and that's what OSHA's trying to do. We're trying to make sure that we make it to everybody comes in and goes home. Why is there no notice? Because employers tend to change things if you give them 24-hour notice or 30 hours notice or whatever. All of a sudden, all the dangers disappear. The stuff that's out of spec gets moved to the trash. So that's why we don't call ahead, okay? The next one that's in there should be, hopefully everybody's are in the right order, there's whistleblower. This what gives everybody in America and the country, Illinois, the right to participate in a health and safety inspection, right? And not have any retaliation. This happens, folks, I'm telling you it does. We get whistleblower complaints all the time. The way I like to do it is think about a fire department. A fireman reports to a captain that reports to a battalion chief that reports to the deputy chief that reports to the chief reports to the board of directors president. In order, as you go up the chain, you're all protected by the Whistleblower Act from any type of retaliation from your employer. You want to think about what might constitute that. I don't know if you have day and night shift. Let's pretend you have 2 shifts and you've been on the day shift for 10 years and all of a sudden after OSHA leaves and you were a participant, you're now transferred to the night shift for no unknown reason. Maybe you scheduled a vacation with your family to Florida to take the kids to the amusement park 6 months ago or whatever, and all of a sudden it gets canceled for no reason. A wage garnishment, anything like that. Those examples on there are real. Again, it happens. We have our own division of whistleblower. They will take down your information and OSHA will initiate an inspection if they need to. The last one in here, I read because I've commented about in the Illinois State Police. I started putting this into, and it wasn't the Illinois State Police, by the way, so let's nix that. But it was a police officer. I started putting this in here to all my inspections. I don't know if the other inspectors do it or not. But again, this is Illinois law on this, how severe and how real OSHA is. So I'm going to read it here just like I was at your facility. I'm on C down there. False statement. A person who knowingly makes a false statement, representation, or certification in any application, record, report, plan, or other document required under this act, or any standard rule, regulation, or order adopted or issued under the act commits a Class 4 felony. Class 4 felony in Illinois, and I don't know if it's the same across the country, I'm not a police officer, but a Class 4 felony in Illinois is punishable by a fine of $75 up to $25,000 per occurrence. That's also on this paper. If the misinformation or the falsification of record or something like that, it leads to one of your coworkers' injuries or hospitalization, fatality, and it's proven in a courtroom, you can do 1 to 3 years in prison. You have to look at OSHA as they're enforcing the health and safety law in the same way that your local community police officer is enforcing common law. You get a speeding ticket, you pay a fine, you rob a bank, shoot a clerk, that clerk dies, you get arrested, you go to prison. In the same way that, say, a DNR agent, if you like to fish and hunt, enforces the wildlife code and common law. You can't shoot 50 Canada geese during the Canada goose season. You can shoot 3 a day. There's penalties and there's prison time on 3 different things. So what my point is we're all public servants. So there's no reason for any public employee to lie. I can get it on the federal side with the private companies because they're worried about their bottom dollar and stuff, but we're all in this together. There's no reason for you to protect an employer that's going to hurt you. So just be honest with your inspector, always be honest with OSHA. I'm very, very proud to say none of my cases have ever went to court, ever, and I hope they never do. I wouldn't know what to do in a courtroom. I'm proud of that. So anyway, back on this. These are some programs that I'm going to ask you for if it's me that's at your facility. I can't speak for all the other folks, but these are what I will ask you for, and I have found that most of this list does apply to water treatment, does apply to sanitary, or so on. So I'm going to go through them more, and if you have any of these type of things at your facility, write down some questions or something. I will save it all to the end for questions, but most of this stuff applies at your facility, okay? Same, continuing on. We're going to go through, and I'm going to be asking and asking and asking on all these programs. And like I said, most of the officers do. Okay, first one. Every single compliance officer in the state of Illinois and in the country is going to ask the employer right away for your OSHA 300 logs. Does everybody know what they are? Does anybody know what they are? You know what they are? Okay. A lot of people don't. This is also the last handout that's in your folder if you want to go through it. I didn't mean to do that, but 301 form is what's filled out when you have an employee injury or illness. It's the detailed description of what happened to Sandy or Bobby or Joey or whatever. Fell off the step, broke an ankle, went to Alton Memorial, that type of thing. You have to fill these out as an employer. The second one that's in there is the OSHA 300. The 300 is a list, chronological list. Nancy got hurt, Joe got hurt, Jim, Kent, whatever. It just lists the employee and an injury happened, right? It's just kind of like a total, if you will. The 300A is besides that handout that I gave you earlier, the labor poster. The 300A is what me and the other compliance officers are going to look in your office to see if you have it posted. That's also law. You post the 300A. And what that has on it is the number of employees at your facility, whatever it is, if it's police department, water department, sanitary, and it has on it the number of employees that are at the end of the year. So if you got 20 people and on December 31st you put 20 people, said use the last day of the year, and it's going to have the number of hours that those people worked. So if you need to, you might have to go to payroll or whatever it is. But you're going to have those forms. If you can't produce these records, they are punishable by a fine. Okay, it's an other than serious citation. It's a record-keeping citation. In terms to keeping all my fingers and toes attached, it's kind of a poo-poo citation, but it's still the law. Police officers enforce all the law, right? Anybody got any questions on those? That's actually a very awesome question. Some municipalities, some cities, I'm not saying that wherever you're from does it, but they track the hours because some places, the insurance carriers request the logs because they want to know the incident rate at that employer. How often does somebody that works for Peoria Sanitary get hurt, right? And what I always say, and what's part of this process, is put your if you represent the city, I know we're supposed to be doing wastewater, but if you represent the city, you want to break it out: fire, police, water, street. And that's because of that insurance type of premium. They might charge you $10,000 to insure 2 policemen, but charge you the same $10,000 to insure 20 sanitary people. The incident rates are so different, right? So that's what the hours are used for. These things also give us trends. This is a true story. I'll tell you the county. I'm not going to name specific employers. Madison County, Illinois, I did a fire department, and I asked for the 3 previous years, which is what I would ask all you for. When HR brought them up, I'm looking through, and I see every year that a firefighter's been admitted to the hospital for smoke inhalation. Every single year. Now, wouldn't that tell all of you something's wrong with a fireman going in the hospital every damn year? What happened is I went through it. It established a trend. So as I go through their respiratory plan and so on, I found out that they weren't fit testing their firemen. Those masks have got to be tight. You're walking into a toxic atmosphere, right? I'm very proud to say that there's not been a single fireman go to the hospital with smoke inhalation since I've left that place. They show us trends, but they're also used for insurance purposes. First one, it's always going to apply to you folks. Wastewater and water plants always have a need for this. Hazard communication, everybody know what it is? Does anybody know what it is at all? Have you seen it? What do you know about it? He's close. He's close. I'm just picking. What's a chemical you use? I don't know. Chlorine. Chlorine's perfect. Number one in water and in sanitation. So I'm just going to ask you directly. If you're working with this gentleman, right? Working normal process in the plant, you're using 12.5% sodium hypochlorite solution. What are you going to do when he doesn't have his safety glasses on, or whatever it is, you tip a drum, a process line breaks, hits him in the eyes? What do you do? And I'm asking you directly, what do you do? That's the key. Everybody overlooks the hazard communication program. Everyone does. I did before I was part of this doing OSHA at the refinery. I overlooked it. The purpose of this program is to tell the employees what they have at the work site. You have 20,000 gallons of 12.5% sodium hypochlorite. You've got 5,000 gallons of sodium permanganate, whatever it is. It's going to tell you what you've got there. It's going to have a chemical inventory list. Why is that important? It's going to be in the front because the fire chief that comes, and maybe one of you are a fire chief or whatever, the fire chief that comes was going to want to see what's at your plant. Show me the inventory list, because he doesn't want to send his team into the back of a building that's got 10,000 gallons of something that's highly flammable or explosive or something like that. He's going to want to see that inventory list. The SDS sheets is when this gentleman was right. Why are they so damn important? We're kind of in the country area here. That SDS sheet is going to tell him exactly what to do with you. Do you flush your eyes with water? Do you not? Do you drink water? Do you not? Do you induce vomiting? Do you not? It's going to tell you what to do before the ambulance, before the paramedics get there. That's the whole purpose. You never know how long it's going to take for the emergency services to get to you. So this is a very important program. Every compliance officer is going to ask you for it. I almost always start with it because you're left on your own until emergency people arrive, okay? Okay, that's another good question too. By theory, the standard says you're supposed to have the SDS sheets for all the chemicals you use. I understand that that's not really practical. What I tell employers and what my position is on it, I'm not representing OSHA, an official position. I'm telling you what my position is when I come to see you, is have the SDS sheets and this information for anything that you're using in commercial or large quantity. And what I normally say is that's 5 gallons or more. You don't have a 5-gallon bucket of sodium permanganate at your house. You've got it at the plant, but you don't have it at your house. A single can of WD-40, this thing, yeah, you're supposed to have the sheet for it, but I'm not worried about it because I consider it household quantity. We can all walk into Walgreens, Walmart, Rural King, whatever, and buy these things. But if you're buying in 5 gallons or more, you're going through it, you're using it. Hydraulic oil, diesel, all that stuff people take for granted, diesel and gas, because we've grown up with it. Everybody knows that gas will put your eyes out. It'll rot them out, right? We all know that because we've grown up with it. But we haven't grown up with some of those chemicals you may use, and they're different. So those are just the two that I know that maybe you guys work with, okay? Training, you don't have to do this every year. You have to train your people initially, and if those chemicals change. So if you've been using the same chemicals for 20 years, then it's when somebody comes in initially, and that's it. But if you change your chemicals, then you got to put the whole team through it again, okay? I'm going to ask you for this. All the compliance officers are going to ask you for this. And there's a perfect example of it right there. You can get them off the internet. If, by the way, I should have said this earlier, anybody wants any of these programs, that's why I stapled my card. I'll send you anything and everything you need. PPE assessment, hazard certification. This is, let's continue with the sodium hypochlorite. If you've got a treatment room, I don't know what you have at your plant, but okay, employee A, when you're going in there to inject 3 gallons of bleach, then you need to have a hood on, you need to have your apron on, whatever it is. You're basically going to use your SDS sheet to tell your employee out of your HANSCOM what you need on. If you work for a street department, we nail the street department all the time because they're using chainsaws all the time and they're always cutting their legs and this and that because they don't wear chaps. I love it when I go to a street department and they pull out the chaps and they look like the guy's rolled in dirt 10,000 times because that means he's using them. Hard hat, safety gloves. You make up this thing for what you see at your facility. Don't make it up on what's on the internet. Make it your own. That's why I have that right there. I hope everybody can see it's not really showing it up. Make it your own. Tailor it to what you do. But an officer is going to ask you for that, okay? And it has to be, since I've got this fancy little deal here, you have to certify it, okay? Date it, certify it. Member of management that said, yep, this is what my people see on a daily basis, okay? Anything else? Emergency action plan. This is another one that people overlook, okay? And a lot of employers, what they pull out is their severe weather plan, and that's a start. It's a good start, especially in the flatlands, in the Midwest, right? Tornadoes. There still are places that have underground tornado shelters, okay? That's fine, but what you need to do besides that, you need to tell your people what to do in the sense of a fire, okay? Do you want them to use, and I actually don't see one in this room, do you want them to use the fire extinguisher that's mounted on the wall or do you not? That determines another thing with OSHA. If it's your intention as an employer for your employees to use those fire extinguishers, then you have to train them on how to do it. But you need to tell them, as the boss man of the wastewater treatment facility, I want you to fight fire or not. Next one happens all the time. May happen to us right now. I've done inspections for several years all across the state. Somebody who doesn't like me because of my inspection results comes in this room, starts blowing me away. You see it all the time on the news, right? See it all the time. What has your employer told you to do? If you're a big guy like me, I'm 270 pounds. I don't really care what my employer told me. I'm going to go after him. But anyway, you're supposed to tell your people, fight or flee. We had a good one. We just went through this in Springfield. All the inspectors and everybody that reports there right by the Capitol had to be trained in our emergency action plan. And our trainer came up with a very good idea. I'm not saying you have to use it, but it's a good one. We started introducing this. Fight or flee, right? Well, how about maybe just get down on the ground? Yes, to the camera, I'm on the ground. I'm on my knees, right? Crawl into an office, lock the door. Maybe you guys come up with, and gals come up with a little code. Knock on the door down here. It's your coworker, let me in before I die. Because the shooter is probably going to be up here pounding and screaming and trying to get in the room. Come up with your own system, but tell your people what to do with that shooter. Hazardous material, everybody, it's not neat because people died, but everybody in this room knows what happened on Interstate 55. The proof is still there. Big hazardous material release, gas products, acid, whatever. What do you want your employees to do, right? Your plan should cover all that stuff, and I will be asking you for it. Respiratory protection, going back to your sodium hypochlorite, if you're using chlorine gas, those things are going to most likely are going to trigger the need for a respiratory protection plan. I'm not saying 100%. I was given permission, so I can go ahead and say it. The city of Greenfield, Illinois, has an excellent water plant. The mayor gave me permission to spread that around. They're open for tours if you want to go see them. It's state of the art. I did not make them have a respiratory protection plan because all the chemicals that they have are contained, closed system, and there's ventilation in the room. They doubled it up, and they don't even have to have a double, right? They've got ventilation at different levels, chlorine sinks, you probably know that. You put your chlorine fans on the low side of things, okay? But they have an excellent plan. If you don't have anything like that, your ventilation, your engineering type of things, then I'm gonna wanna know, because I'm gonna go back to that HAZCOM program that you already have, and I'm gonna pull out your SDS sheet, and I'm gonna look, and when you show me methyl ethyl death, I'm gonna look and what it says, respiratory condition or not. And if it says respirator required, I'm gonna say, where's your respiratory protection plan, okay? So go through the chemicals you got. If anything, for your employer, or your employees, but for yourself. Know what you're dealing with, okay? Part of the program has to be written, okay? It's not verbal. Part of the program, you gotta name a program administrator. It can be the boss, it can be a frontline worker, it can be the shop steward, it doesn't matter, but somebody needs to make sure that that program's staying up to speed, that it's being reviewed annually and that you're keeping track of all the respiratory hazards. Medical evaluations are part of a respiratory protection plan. Employers get this wrong all the time, so I'm going to spend a minute here. Medical evaluations are not physicals. I'm not telling you that you have to send 30 firemen to get a physical. What me and the other inspectors are telling you is that you have to pass out this questionnaire. I'll send it to you again if you email me or something. You have to pass out a medical questionnaire that your staff fills out right there on a normal work day or a training day or whatever it is. And then either the employer sends it to a licensed healthcare provider, which is a doctor, of course, nurse practitioner, licensed nurse practitioner, EMT, paramedic don't work. You can't do that yet. But they're going to look at that paper. I should have said also, as an employee, you can send it to your own personal doctor. I forgot to say that. But the physician's going to review that information, which is just written, and say, yep, okay, pass, they can wear a respirator. Or they're going to say, no, I have to see you in person before I'll clear you for a respirator. That's when the physician visit comes. But I get a lot of fire departments that send their whole brigade and they say, Joe, this just cost me $3,000. And I'm like, you didn't do what I told you. Just send them the information first. Then you send the people that the doctor requests. A big one for management, if there's management in here and you are having this respiratory protection plan, those forms are going to come with one of 4 boxes checked for your clearance of your employee. It's going to be indefinite, 1, 2, 3 years, right? Somebody young, spry, skinny, in shape's probably going to get an indefinite mark. Somebody who's a little bit overweight in their 50s now is probably going to be a 1 or 2 year. That's going to say how long it is before you have to be medically evaluated again. You put that in the employee file. You're only putting the pass-fail. You're only putting the amount of time of the evaluation in the employee file. If they hand you personal medical information, you hand it right back to them. All you want is pass-fail. Different from the fit test. Different from the fit test. A fit test is every 12 months. It's annually, period. Okay? That's the difference between those two. Again, employers get it wrong and it costs them money all the time. Fit test every year. And you also want just the pass-fail. Whether you're the employee or you're the management, think about going in with paper and coming out with paper, and you want your name and date on it. You want your physician's name and date on it. Don't come out with an electric printout. Don't do that. Bobby Jones had his fit test. It's not going to stand up in a courtroom. Make sure you're signing things. Your physician is signing things. The old handwritten signature still means more than this electronic stuff, right? I never even had one of these things on before. Fit tests. Annual, and I think just about everybody in here knows who Luke Skywalker is, I hope. Good old actor, right? Use the Force, Luke. Well, perfect example of another reason that you would have to have another fit test. When the original movie came out, we all fell in love with Luke, right? Everybody loved him. He killed the Death Star and all that stuff. But Empire Strikes Back is the second movie. When Luke shows up riding that Tauntaun or whatever it is, that ain't Luke. We didn't recognize him because he got in a car wreck. Okay, that's what happened to Mark Hamill on a back road. His face got disfigured. George Lucas, being the genius that he is, put in that sloth scene or whatever where he hits Luke in the face. That's why we see Luke after that is that facial reconstruction because of his accident in personal life. That would trigger another fit test. The mask doesn't fit the same. If you gain or you lose significant amount of weight, I've said, what's significant? I've been told to say 20 pounds. That's the best I can give you. If you keep on 20 pounds or keep off 20 pounds and it's for good, you should probably refit test yourself. Is everybody clear on the difference between those two? Confined space entry, most of your plants, I don't know what you have, but I'm going to ask you for it probably. This is going to be your underground vaults, tanks, manholes. Street departments typically go in manholes. City of Edwardsville, a private contractor, just lost 2 people. You may have heard about that. That's not too far away from here, about 2.5 hours south of here. 2 guys died in a confined space. The police officer got out in time. But anyway, I'm going to ask you for your confined space plan. If you have them, if you got confined space, I'm going to ask you for your permits, and I'm going to be the old permits too. When you get these permits filled out that show your oxygen level, your CO2, hydrogen sulfide, whatever it is, keep those permits for 5 years, okay? Training, your people have to know what that confined space is. In your written program, you should say, Greater Peoria Sanitation District has confined space in the form of 3 underground lift stations at 3 grain bins at. You should identify the spaces so your employees know. You're going to train them on how to use that equipment. Maybe it's going to be, here's another part of that, are you going to do the rescue as an employer yourself? Are you going to contract it out, right? Are you going to have the tripod and the harness and the 4-gas meter and everything that you need? Are you going to train your people that says, guys in the hole, you're here, you're the hole watch, you don't leave, period, right? You don't leave a guy in the hole, right? Guy or gal in the hole. But training is a big part of this. Most public utilities now are getting away from it and they're contracting it out. But if you're going to do it, you got to do it right, and your people got to be trained. The answer also for rescue is not, I'm going to call the fire department. Because you're going to find, and you can call around, you'll find that not all the fire departments are going to answer the call for confined space anymore. The fire chiefs have told me that directly to their face, or to my face. You need to call your fire department to make sure they'll come rescue you. Lockout, tag out. Not a lot, but some of the water and sanitary plants do need this. Typically, what's most involved is electrical panels. But like I said, with a confined space, most companies now, even public utilities, are contracting out the electrical so they don't have to worry about it, right? But there are different things. I audited City of Edwardsville Street Department 2 or 3 weeks ago. You wouldn't think it, but they're a pretty big city, right? But they've got a huge fleet of vehicles. At that department, they have a lockout, tag out for maintenance on their street vehicles, okay? So if you need it, you need it. Hydraulic energy, is oil or water, pneumatic air, chemical, obviously chemical, thermal, heat. Do you need it? I can't say. Some of you do, some of you don't. The best thing I can tell you is if you need it or not is if you're out of line of sight. If you're working with something that you don't have the control of and you can't see the person that does have control of it, you're out of sight. You should probably have a lockout, tag out program. It should be written. It's simple. Sign in sheet, sign out sheet, what's locked out, who, where, why, and all that stuff. They're simple. The damn procedures I send people are 2 pages. And you enact it. This happened, and I always try to give live examples because this program was not followed. There's a man down south now, Madison County, who's missing his thumb in the last 2 years. And the biggest thing, it kind of upset me because I showed you that picture of the guy holding the fish. This guy is just getting ready to retire. His biggest hobby is golf. Can't hold the golf club anymore. If you got to use a lockout, determine that. You want to control your energy, okay? It happens to people all the time. Bloodborne is common at sanitary. Some plants need it, some don't. This is all going to depend on what type of engineering practices you have in place. But if your employees are what's called occupationally exposed to bloodborne pathogens, which basically all the fluids that come through, bodily fluids, needles, feminine napkins, any type of thing that has blood on it. Sanitary people often encounter that. So if you have the occupational exposure, you're going to have this plan. Some people, some cities identify it. Operator A is occupationally exposed, whatever the case may be. There are very few sanitaries that don't. But some have engineered to where their people never touch the fluid. They never, nothing. They don't ever touch it. It just depends on what you got. I talked about the City of Greenfield water plant. Well, hell, it's $2.7 million in a building about this size, but it's up to date, state of art. A 100-year-old facility don't have that. So you might have exposure. If you do, then you have to, your employer, and if you're not the management sitting in this room now, then you need to ask your employer for a Hep B shot. The employer has to offer you a hepatitis B shot within 10 days of employment. You don't have to take it. It's up to you. But they have to offer it to you, okay? And if they don't, if you are the management side of things here, you're going to want to get the declination form. If your employee says, no, I don't want it, you sign a form. All this comes in like pre-written exposure plans that you modify for your own. There's a declination form in there. On the other side of it, if your employee says, yes, I want the shot, then you get proof. You don't get their medical records. You just get an invoice or something that says, Joe Blow, vaccinated for Hep B, okay? I've been asked about duration of it. Nobody's given a real good answer, but we're kind of starting to come to the point of if you've had the Hep B shot over 10 years ago, you probably ought to go again. But there's no science backing that yet. You can get an antibody test to see if it still triggers, but I don't have the concrete answer for that. Annual training every year. There's no how do they say that, if, ands, or buts. You have to train your employees every single year. It doesn't look like we have any really spring chickens in here. Said I'm 51. Think about why you do the annual training. When most of us went to the doctor when we were this tall, oh man, here comes the needle, right? We all went, oh, he just smiled back there, right? We went, oh shit. Now, you don't ever even see the needle. It's under the protective sheath that goes into your skin. The sheath covers the needle. You never even see it. That's an example of annual updates. I'm sorry I did that. Annual updates to bloodborne pathogens. Maybe there's the newest, best nitrile glove for you folks. Maybe there's a better apron. The other thing that this tells you, your employers, happens all the time, is what to do with your bloodbornes, okay? If you have an injury and you're helping your coworker out, you've both been trained in bloodborne pathogen, what as an employee or what as an employer, what do you tell your employees, or what should you do with all the waste that's generated? Do you have the red biohazard things on your site? Or is it going to be employer practice when the ambulance or somebody comes, send that material with the ambulance for disposal at the hospital? You don't want to throw it in the trash can and then have your child who's visiting on Mother Parents Day sit there and play with the blood that's in the trash can, right? I try to give examples, you know. A lot of people always open up. This is some examples of engineering stuff that when I start walking around your plant, I'm going to look. Up here, there's all kinds. This is recent photo. I don't know if anybody knows what it is. This is an electrical panel. There's 5 things we're going to look for on your electrical panels. Number 1, this thing, my hand's not really steady, right here is called the dead front. We're going to make sure that the dead front's in there. A lot of the older facilities, it's been removed. Second thing we're going to look for, you can't really see it, but are all these slots filled? Are all the circuit breakers where they're supposed to be? And the reason for both of those is because you trip and you fall and you stumble, and all of a sudden you put your fingers or your hand in the bus, and Joe Blow's no longer standing there, and you're going to go visit him at a funeral after he got electrocuted. And why might he fall or she might fall and trip? Because this is a violation right here. You can't have things in front of your electrical panels. That's across the board. We cite everybody for that constantly. You have to keep open space in front of your electrical panels. The general rule of thumb is 30 inches or the width of the equipment. So what we tell people, and almost all the fire departments do this, move this stuff. Go to the hardware store or whatever, get that black and yellow tape and put it on the floor and remind people that nobody's supposed to go next to the panels, right? You're not electricians, but that's a violation we look for. Right here, if you can see that, all electrical connections have to be inside of boxes under 8 feet. You don't want to trip and stumble into a live line that's not covered, or what do you call, the cap has come off, or you get shocked or whatever. We cite these types of things all the time. So, there's an example of 4 or 5 different violations. Labeling. The fire chief wants to know. I'm telling you that right now. He wants to know in the same way that he wants to know about the hazardous materials that you have on the property and the chemical inventory list. He wants to know how to kill electrical power if he's got to send a team in, but he doesn't want to kill the whole facility. He'll want to know what is what, or she'll want to know, I'm sorry. This is a big one. We get them all the time, almost every wastewater treatment plant I go to. Your chain hoists and your electrical hoists, if you're a mechanic, your hydraulic hoists have to be inspected annually, every year, period. You got to have them inspected. And you'll find, I don't think I've maybe had 1 or 2 sites that something didn't come back on the inspection list as faulty on those hoists. Maybe it's a pitted chain. This hook here, what they'll do is they'll measure the diameter in between right here and see if it's stretched or not. That's got to be a certain spec for that hoist. They're going to see, and I can't tell myself if it's on there, if that latch is on there. They're going to look for that. Like I said, pitting on the chain. You've got to inspect them manually. You're going to get that citation all the time if you don't. Exit signs. If I was doing this building, I'd go over here and tap it. There's test buttons on it to see if it works. Floodlights, see if they work. I get asked this even by fire chiefs, believe it or not. Here's the rule on these things. I don't know, does this building have a backup generator, backup power supply? Kent? Okay, all right, if it did, if this had a backup power supply that is automatic and not manual, you don't have to have those floodlights, okay? Because the power is automatically coming on. If you don't have backup power or it's a manual switch on a generator, then you have to have working floodlights, and that's because your employees have to have a visible route of egress to get out in the sense of an emergency. So that's how that works. Exit signs, I don't know where those 2 doors lead that are behind you guys, but since there's exit signs here, I hope they're leading to closets. This room seems to be marked right. But we find this all the time. There's one light hanging down. This one's broke. The funniest story I got on that is we got into a fire department, and we start walking through the bays, and the chief's, he's walking with me like this because he knows, because I look up at the floodlight, and it's just shattered, right? And I keep going, and we get to 5 in a row. Well, the firefighters are playing football in the bay, and the extra point is who can kick and knock out the floodlight. Funny shit, right? You ain't gonna believe why, Joe. I was like, well, okay. So that's a true story, though. He got them all replaced. Big at water plants, big at sewer plants right here. Machine guards. If the pump is gonna turn on, or the grinder, whatever it is, automatically, Have your machine guards in place. 90% of the time, as was this case, these are my photos I took. That's at a water plant. The machine guard right there for the spindle is sitting right next to it. People do maintenance and they don't put the guards back on, okay? Keep the guards on. If it's a manual flip on, some type of whatever your equipment is, I'm not so much worried about it because you have to physically know that you're turning it on. But if you're at a control booth and he's over here, he doesn't know, she doesn't know when you're going to turn that pump on, right? Some more. This here happened. I've seen this twice in the last month and a half. Flexible, first off is this the, what do you call it, power strip, like right there. Don't piggyback them together. They're not designed for that. You see that all the time. One strip, don't piggyback them. Flexible extension cords. This stuff, we cite it all the time. They're not designed for continuous use. You don't staple them to the wall to run a pump in the aeration basin or whatever and call it good. And the thing we see most often is they're using 16 gauge wire, the small little extension cord. It will overheat. I'm not going to name the city, but it's also happened in the last 2 months where I walked up to the cord that they had stapled all the way around the building to the restroom that was feeding a radiant heater. When I went to touch it, it was so hot it almost burned my thumb. Don't use flexible cords for permanent wiring. Get it wired the right way. One of the most common citations we issue at water plants, sanitation plants. Get it wired right. Grinder, there's all kinds of things on grinders. Almost every utility department has one of these. I've got one at my home. Right here, this is called the work rest. All your inspectors are going to look for it. It's got to be within 1/8 inch of the wheel surface turning. And you have to adjust that as your grinding wheel, or that's a brush on this right-hand side. As it wears down, you have to adjust that work rest. Up here, underneath this little thing, a better shot over here, it's called a tongue guard. That's 1/4 inch away from the grinding wheel. You don't think, you might be sitting there going, this shit don't matter, Joe. Well, I could show you a film of a camera, right, in a warehouse where the guy's on the night shift by himself. The guards weren't on there. The spindle exploded, went straight through him, and they found him bled out dead the next day. Those guards will protect you if those grinding discs come apart. To that extent, right here somewhere on this thing, if you have grinders at your place of employment, there's going to be an RPM thing on there, 3450, whatever it is. When you send somebody out, or you yourself go out to buy a replacement wheel, make sure it's rated for that speed. You don't want to buy a 1500 wheel on a 3500 unit and fly it apart, right? Make sure they're rated the same. You can do a ring test. A lot of the old timers know what a ring test is. You put that wheel that you just bought at the hardware store on a screwdriver, on a pencil, whatever it might be. You spin it and you lightly tap it. Don't blast it. I'm not telling you to blast it. Lightly tap it with some metal, maybe a hammer. If it pings like china in your kitchen, the wheel's intact. If it thuds, it's got a fissure. It came manufactured the wrong way. It came not fully compliant, well, whatever, and it's got a higher chance of breaking apart on you, okay? But there are deaths that happen. This, I also cited this employer right there. Most drill presses, grinders, miter saws, stuff like that has to be permanently anchored so that it can't walk or move on you, right? You got some of those drill presses are heavy stuff. You trip and fall, or you push and pull, and that thing will come over on you. You got to have them mounted. You don't have to have it secured to the floor. You just have to have it secured. In this case, this employer just sent me the picture about 2 weeks ago, and they took some angle iron and shit, and they mounted it to this. That's fine. It can't move. It's just got to be anchored. Example of the electrical panel again. You got to get all this stuff moved. Fire chief wants to get in there. I firmly believe this. I've never not given a presentation, because I don't give presentations, but I've never really done an inspection where I don't cover this. It's one of the truest things I think I've ever seen. Hierarchy of safety, it works. Elimination, If you don't have to enter that confined space, don't. You've eliminated the hazard from your employee. He's not going to get engulfed. He's not going to get asphyxiated. I can't ever say that word. Eliminate the hazard. If you don't have to clean your water tower, subcontract it to a professional. It's a confined space. Eliminate, eliminate, eliminate. Substitution, all where everybody lives, it doesn't matter what. All the fire departments in the country and the state in the last couple of years are all substituting the non-fluorine, fluoride-filled foam for the new stuff that's safer for human beings. Our public servants are doing it all over. What I say for the wastewater and water plant, this is where if you're using 20% sodium hypo, knock it down to 12.5%. If you can get away with 6% bleach, household bleach, use the 6%. Use the least hazardous material, or put yourself in the least hazardous condition that you can, okay? Engineering controls, that's those tongue guards on that wheel. It's a man-made interference between the hazard and you. It's a guardrail on the stairs, these exit signs, engineering, man-made. Administrative is becoming more and more prevalent. I'm getting a lot of this for confined space and stuff. People ask me, how do I abate that citation? Well, maybe you're the mayor of Jonesville or something. Administrative, by order of Mayor George of Jonesville, employees of Jonesville are no longer allowed to enter confined spaces. It's an administrative order that tells you, your employees, they're not to go in there. It's universal. Send them out with the paychecks. If you get electronically paid or whatever, have a meeting, have a sign-in. But it's an administrative order, and it's effective. When we had the stuff in front of the electrical panel, put a little sign there. Don't put anything within 30 inches of the electrical panel, okay? It's administrative controls. PPE is the last thing. You all have heard this, I know. PPE is always last. Your steel toes, your hard hat, safety glasses, gloves, chaps, whatever it may be. But this is the reason, this is my favorite part of this. Why does it work this way? Who's ever heard this before? Why does it work that way? Anybody know? No? You don't know? Down here is human judgment. We're all flawed. We're all humans. We make mistakes. Up here, there is no human decision. It's gone. The hazard can't hurt you. Down here is the fireman who's got a 30-minute air bottle, and he looks on his air gauge, and he's got 10 minutes left, and he hears the baby crying across the apartment floor. He makes that decision to go try to rescue that child. On his way, he falls through a floor joist. He runs out of air. He dies. Child dies too. He made the decision. And we make bad decisions. That's the bottom line. That's why this works this way. On this side of things, you can see that. I don't know if everybody can see it or not, because I can barely see it. Policy, procedure, that's what all these programs are. After I leave here, if your management, get these things going at your facilities, because we're going to be looking for them. Policy, procedure, policy, procedure. Make one up, train your people. Put a training record right behind it. It protects you as an employer, right? Because you're teaching your employees. But it protects them because it should be telling them how to do their job safely. It works both ways. Policy, procedure, supervision. Someone in here is probably called a superintendent or something like that. Supervision, you're going to use that grinder. Bobby, this is the third time I've seen you without your safety glasses when you're using that grinder. You note it. You supervisors, stay on your people. This is where the battalion chief's hitting the rank and file firefighter for not checking his air bottle before he goes in that is at 90% or greater. Whatever it is, supervision. Enforcement is the discipline part of it. If you sit there and you got to enforce what you're trying to have your employees do. This is discipline, suspension, whatever it is. And this is a big one. Everybody thinks union. I'm a member of union, right? But I'm going to tell you this right now. No union is going to protect the employee whose employer has documentation that employee has consistently, willfully violated the health and safety protocols. Union is going to have no stance. Simple. It's simple. Closing conference, this will be what happens at the end. We'll go over everything that we cited based on all those things. A typical plant may have 10 citations. Bad ones have 20. If you're good, you get out with 2, something like that. A lot of people don't know how OSHA process works. The citation packet will go to the highest ranked official. If you're in a city, it'll go to the mayor under green card mail. If you're a fire protection district, it'll go to the board president. The thing that happens when that green card comes, whoever signs for it, it's the first clock that OSHA enforces. You have 15 working days to do one of 3 things. First thing is you agree with the citations, you're going to fix them. You don't do anything. Second thing is an informal conference. What happens there is, you remember in the beginning I talked about how management, union, and worker are part of this process. At an informal conference, those people that attended are either going to get on a webcast because of COVID, waited all computer and all that stuff, or you'll be asked to go to Springfield, and at that conference you can argue anything you want. Severity of citation, there's 4 different levels of citations, penalty, abatement time, anything you want. It's informal. The last option that you have is a formal contest, and that is where your municipality lawyer, your legal representation, drafts a letter that says, hey, OSHA, pound dirt, we're not doing anything. That letter comes to my desk, I take it to my boss, he takes it to legal, and 3 years from now you can fight it out in a courtroom if you want. None of my cases have ever went to court, and I'm very proud of that, because I'm not going to write a citation unless there's employee exposure. Unless one of my brothers and sisters are going to get hurt, I'm not going to write a citation. And I told you I have been to the hospital for my job. PMA discussion, or abatement periods rather. The federal government changed all the state plans. Illinois is a state plan. You're going to have 30 days to abate the citation. We can no longer change that. When I first started, we used to be able to give you up to 90 days. It's not that way anymore. You have 30 days to fix it. PMA, petition for modification of abatement. That's a single-page form. If you as an employer think you can't get something fixed, that chain hoist we know has got a bad hook on it, but our vendor can't get out here for 3 months. You fill that form out, you tell us why that you can't get it fixed, and you say what you're going to do in the interim. I've made an administrative order, as we now know what administrative order is, that no one is to use that chain hoist, or we locked and tagged it out. There's ways of getting around things until you can get the problem fixed. I've only denied 1 PMA, right? 1. To a fire chief, and he deserved it because it was simply for training. Wasn't going to cost his district $1. Just get his team, just like this team has met for this meeting, just get his team together and train him, and he didn't do it. So I fined him. That's it. I don't know how else to say that. Only one I've ever denied. But it goes to a second level. I report to somebody just like everybody else does in this room, goes to a second level. They will deny them. He will deny them if they're unreasonable. If you get inspected in the next couple of years, don't wait till the last minute to request more time. That makes them upset more than anything else. Ask for time right away when you know you're going to have a problem. And the best thing I can say is remember those policy and procedures. Remember that triangle. You all had a pen. I'm going to close up real quick. I want you to do this with me. You got a pen. Come on, open up the folders. You can do it. It's not going to be hard. There's no trick. Draw 2 lines right there. Draw 2 lines or on a piece of paper that you got. Come on, brother, get into it. You have a pen? Come on. All right. Everybody got their 2 lines? Real simple. Think about you're sitting at home on a monthly basis, right? Do it just like you would. Here's my name. Sign your check. Just pay the electrical bill. Go ahead, sign it. Now that quick and with that ease, sign it with your other hand. That's why I'm here. Untie your shoe. Try to tie it with one hand. Zippers on men, and I think they're backwards on men and women's clothing, but the next time you're in the restroom, I know guys, zippers are like this. Try to unzip your zipper in your pants with one hand, right? That's why I'm here. I got all kind of examples like that. Do this when you get home, and then I'm going to shut up, and it's over, and you can ask questions. Everybody in this room's probably got a kitchen. I'm assuming you do. Probably got a trash can in it. Probably do. Go home and move that trash can. And then for the next 24 hours, just like there's one right here, why don't you mark down on the tab how often you go like this and the trash can's not there? Or if you don't want to move the trash can, take the bag out of it and you go, oh, I don't want to throw something in there. We're creatures of repetitive motion. If you train safely, you're going to keep yourself most of the time. I don't know. I've done that to myself so many times. It's disgusting. Shit. Just threw something in the can, right? I went through a lot of programs and stuff. There's questions here. Anybody have anything? It was my mission to, I hope you learned. I hope it's better than, just sitting there and watching a video. Anybody have any questions on any programs at all? Anything?
So the SDS, I think it was 2000 everything, AGS. So in your SDS program, everything has to be changed over to that, correct?
What he's talking about is in 2012, they went to I can't, if I get it all right, global harmonized system. What you're supposed to see now, and this is, I think it's in the United Kingdom too, but I know it's in the US and Canada, all your safety data sheets are configured the same way if they're after 2012. And it really did kind of revolutionize the process. So when you find your dangers of your sodium hypochlorite, you can go to your sodium permanganate in the same place in those sheets and find those dangers. They are supposed to be updated. If your sheet says material safety data sheet, it's obsolete. Your sheet should say safety data sheet. When you get new chemicals, replace your sheets. You got to train your employees. You just change chemicals, right? Even if it's sodium hypo from Hawkins Engineering and you switch to Beelman's products or whatever, there might be a little trade difference in there. It's just the active ingredient is 12.5% whatever bleach. But, so, anything else?
Something that we've done that is, throw out there. So we've had meetings with the fire department, and we actually have a box here that has a map and where all of our chemicals are. So it's a good idea for other municipalities probably. That way when something does happen, ours is in a lockbox. They have the keys to it.
Put the map in the hazardous communication program, and that reminds me of something that I didn't say on the emergency action plan. All of us in this room know what it is. If you've ever stayed in a hotel, you walked in the hotel room and you shut the door, what was there? A map. You should have those at your facility, because maybe Junior, who just started, doesn't know that there's a fire extinguisher underneath the staircase that he's standing on. Maybe he doesn't know that there's another exit door out there. A physical plan on a door does a lot. We all associate with that. So. Yeah, unless you have proven it's a non-permit required by repetitive error monitoring and backup data. You just can't, if I walk up on you and you're in a confined space and you can tell me nothing and you just simply say, I've always done it this way, it ain't gonna fly. You'll want to have backup data that says you have historical that says the space is free of engulfment. What happens in those spaces is oxygen is depleted. Whatever the gas is takes over the oxygen and pushes it out, and that's why we all die or whatever if you get out of breath or whatever. One that I heard of, this really surprised me. I heard of some deaths from regular base rock. If you live in the country, like my driveway is made of base rock. I heard a couple of people dying in an underground vault because the lime and stuff in that rock reacted with something, and they found them dead in the vault. It's a while back, but answer your question, if you can't prove that it's not got a hazardous atmosphere, then you got to go through the whole process. Yeah, through historical data, air testing, monitoring, nothing's ever changed. This vault's been this way for 100 years. And you can, when we talked about ventilation and respirator protection program, a lot of the sanitary districts now are going to simple ventilation in your lift stations and in your underground vaults. It doesn't cost much. You put an influent air pipe, an effluent air pipe, change that air, minimum of 6 times, up to 10 times an hour, and don't worry about it anymore. I mean, get your air samples and all that stuff, but it's very effective and it doesn't cost the employer that much. I always stick around at my inspections for like 10 or 15 minutes. I'm yours. I thank you for what you do. I hope you learned something, but I'm officially, I'm done. Thanks. I don't speak. I'm a compliance officer.